Hello everyone, and welcome back to the tutorial. In this video, we will be constructing the login screen that you guys briefly saw in part 1 of the series. In order to do this, we need to create what is called an Amazon Cognito user pool. And through this user pool, we can leverage Cognito's built-in features to automatically generate a website that will have all the authentication features we need, such as signing in, signing up, forgot password, as well as signing in through a third party such as Google. Then, once we have this website, we can add it to our Unreal Engine game client, and upon a successful sign-in through this website, the client will receive temporary Cognito user pool tokens, which will allow the client to authenticate itself to the client service, which in this case will be APIs on API Gateway that call Lambda functions. This way, the APIs will know who the client is and can reject or accept incoming requests based on the credentials passed. And these APIs will be authorized to access specific AWS resources and services. All in all, Amazon Cognito will help us better secure our application. Before we get into the main crux of this video, which is authentication and authorization via Cognito, I have to go over some misunderstanding from the last part of the tutorial, mainly concerning FlexMatch event notifications. As a result, just warning you guys ahead of time, we will have to recreate our matchmaking tickets table and slightly modify our Lambda function subscribed to the SNS topic, receiving event notifications from the last video. Here, I am signed into my AWS account on the AWS Management Console page, so let's go back to the Lambda function, which was called track events from the last part of the tutorial. So let's click on track events, and then let's scroll down to actually modify our code. And the first thing I'm going to address is this type to rank variable we have up here. We're going to get rid of this. And we're also going to get rid of where we set the rank attribute in each item we write to our matchmaking tickets table. So let's scroll down, and of course let me zoom in. I should have done that earlier. So this rank attribute here where we set it, for me it's on line 46. Let's just get rid of this line where we set the rank attribute in each item we write to our matchmaking tickets table. Now, I know that we established before that the rank would be a sort key that the table would use to store multiple ticket items with the same ticket ID. If we go back to all the possible FlexMatch matchmaking events, link to this article will be in the description below. On the right side are all the event types. Ignore the events of type accept match and accept match completed because our matchmaker does not require acceptance, so we will never get those types of events. The last 4 events, including matchmaking succeeded, matchmaking timed out, matchmaking canceled, and matchmaking failed, are what we are going to call final result notifications. So once an event of any of these 4 types happen, then the request is finished and there will not be any more events in the future involving that matchmaking ticket. Before reaching those final result stages, the request could potentially go through the matchmaking searching and potential match created stages. But according to a representative from the GameLift team, these matchmaking events are considered noise, while the final result events are considered actionable. Therefore, we should only store the actionable events in DynamoDB since the clients can actually act upon those. For example, if the ticket ends up in matchmaking succeeded state, then the client can join the server. Otherwise, if the ticket ends up in any one of the matchmaking timed out, canceled, or failed states, then the client knows that the request is over and they have to start a new one if they still want to join a match. The other 2 possible events, matchmaking searching and potential match created, don't tell the client anything useful really. Matchmaking searching means what it sounds like, in that the client has not been placed in a match yet, and the potential match created event doesn't guarantee that a game session started on a server process. It just means that FlexMatch was able to place or make a match with a group of players using your matchmaker's rule set. Essentially, once a quote-unquote potential match is created, FlexMatch will look for a fleet that has an EC2 instance with an available server process that can host the game session. But the success of that is not always guaranteed. Therefore, assuming that the action to start a matchmaking request is successful, the client can always assume that they are in a quote-unquote searching status until one of the 4 actionable events occur. So if we are only storing these one-time matchmaking events, then the most number of items that we will write to this DynamoDB table for a specific ticket ID is 1. That is the reason why we no longer need the rank sort key attribute. With that said, we still have to make some further modifications to our Lambda function. So let's go back to Lambda, and we just got rid of the rank attribute, but we also have to filter out those noise events that we just talked about and only write items to the matchmaking tickets table for actionable, aka final result events. To do that, take the for loop here, for const ticket of message detail.tickets, and we're gonna put this inside an if statement. So we're gonna add right above it, if parentheses message detail.type equal in quotes matchmaking succeeded, double pipe to signify the or operation, message detail.type equal quotes matchmaking time out, and then double pipe again, message detail.type equal in quotes matchmaking canceled, and double pipe message detail.type equal in quotes matchmaking failed. And then we're gonna add a squiggly bracket at the end, and we are not going to add a closing squiggly bracket. We're first going to take everything inside this if statement and we're going to tab it, and then after this last squiggly bracket before the await keyword, we're going to add that closing squiggly bracket right there. Don't forget to save your changes by clicking on this save button on the top right here, and if you are unsure of the exact code of this Lambda function, then don't worry, for we will have a link in the description below to the GitHub repository for all the Lambda code we write in this tutorial series, as well as test events for testing out these Lambda functions. The next thing we have to do, since we are no longer using a sort key, is recreate the DynamoDB table, which should not be too hard. So let's go to the DynamoDB dashboard, go to tables on the left side here, select the matchmaking tickets table that we made from last time and click on delete table, and type the word delete in this text box to confirm, and then click the delete button. Once the matchmaking tickets table is finished deleting, let's recreate it by clicking on the create table button. For the table name field, same as before, we are going to call it matchmaking tickets. For the primary key field, we are going to call the partition key ID like last time and keep it as type string, but we are no longer going to add a sort key, so leave this add sort key checkbox unchecked. And I think I may have mentioned this in the last part of the tutorial, but we are going to leave the use default settings checkbox checked for every single table we make from now on in this tutorial series. The reason why we had to uncheck it before is because we had to create an IAM role that enabled permissions for auto scaling. You will notice that the warning that said something along the lines of you do not have permission to set up auto scaling by default is no longer there, because now you do have permission. So click on the create button to finish creating the table. After the table is finished being created, let's not forget the last thing we need for this table, which is a time to live attribute. So by where it says time to live attribute, click on manage TTL, and for the TTL attribute, we're going to name it the same as we did before, just TTL, and we are going to click on continue. Once time to live is enabled, just want to mention, if you have extra time after recreating the matchmaking tickets table, you can test the modified Lambda function using the test events in our GitHub repository with all the Lambda code from this tutorial series, as well as test events. Link will be in the description below. We covered exactly how to configure these test events in the last part of the tutorial. Conveniently, since we recreated the table with the exact same name as before, we don't have to change any IAM policies or roles related to the old table, because the resource ARN value of this new table will exactly match the ARN of the old table, assuming you remade the table in the same region on the same account. And essentially, you just want to make sure that the Lambda function only writes events of type matchmaking succeeded, canceled, failed, and timed out to our table, because like we mentioned before, these are actionable events, while events of type matchmaking searching and potential match created are ignored since they are considered noise events. So just to show you guys, if I click on the drop down menu by where it says test, and you'll notice I have a few events configured here, but I'm going to select on the matchmaking searching event, and I'm going to click on test, and you'll see from the response from this Lambda function that an error response was returned. And according to the message inside this error, it seems to be because in the batch write item request that we specified, we didn't have any items in there. And if you go to the DynamoDB table and refresh, you'll notice that no new items appeared. But if you go back to the Lambda function and this time under the drop-down menu, select the matchmaking succeeded event, which is an actionable event as opposed to the noise event we just tested. Click on test again. This time you'll get a successful response return. If you go back to the DynamoDB table and refresh, this time an item is written to the DynamoDB table. And this is kind of what we want, right? We want to acknowledge those actionable events and we want to ignore those quote-unquote noise events, because these final result matchmaking event notifications are going to tell the client the outcome of their matchmaking request, whereas events of type matchmaking searching and potential match created don't really give the client any useful information about their matchmaking request. If you want to get really fancy, you can do what we did in the last part of the tutorial and publish test messages to the SNS topic. So let's go to the SNS dashboard, go to the topics on the left side, and then click on the topic we made, which was called Flex Match Event Notifications. And then click on the button here that says publish message. And go back to the page with all the possible flex match matchmaking events. And this time we're going to go to the potential match created message and just copy the text here in this grayed out text box by clicking on this clipboard button on the top right corner of this grayed out text box under where it says example. Go back to the SNS page, and then underneath in the message body, just go ahead and paste that raw message. And then click on publish message. And because potential match created events are considered noise, we shouldn't have any new items in our DynamoDB table. And as we saw after refreshing the table, nothing was written to this table. Nothing new was written to this table. If we go back to the SNS topic and publish a new message, let's go ahead back to the list of flex match matchmaking events, and this time let's go to one of those actionable events. We did matchmaking succeeded before. Let's do matchmaking timed out, and once again click on this clipboard button underneath where it says example on the top right corner to copy this message. Go back to the SNS page. In the message body, just paste that raw message. And let's click on publish message again. This time if you go back to the DynamoDB table and you click on refresh, you will see a second item now, because this is an actionable event. So this table will now only store at most one item per matchmaking ticket, and that item will only be one of 4 types that we discussed earlier: matchmaking succeeded, timed out, canceled, and failed. Last thing I want to note is that what I just said mainly applies to matchmakers that don't require acceptance. If the matchmaker does require acceptance, then the structure of the table and logic of the Lambda function may change, but not by much. Now, in the last part of the tutorial, I mentioned how the order in which messages are published to the SNS topic does not guarantee the order in which the actual events occurred in. This is still true, however, there is another timestamp field that you can use to find out when the flex match matchmaking event was generated rather than when it was published. By the way, just to clarify, when the message was published, in this case means when the message arrived to the SNS topic, and that value can be found in the SNS metadata associated with each message sent to the Lambda function subscribed to the topic. I'm going to pull up this forum post I made about a week ago just to show you guys a very simplified version of what the event object passed into the handler function looks like when the track events function is called for every time a flex match message is published to the topic. So the event object has a bunch of fields, but the one we care about is the one called records, which you can see in the top half of the page. This records this records field is an array that always contains one object. Again, I don't know why that is, but the record has an object called SNS, which not only has the message, but a field called timestamp. This timestamp field is when the message was published, but the actual message itself has a field called time. And you can see what the actual message looks like in the bottom half of the page here in this forum post. This time value is when the event occurred. So if you ever did want to order multiple events to a matchmaking ticket by some value or sort key, I would recommend using this time field. But again, the GameLift team only recommends storing actionable events in DynamoDB. So you shouldn't have to store multiple items per ticket in the matchmaking tickets table, even if your matchmaking configuration does require acceptance. Unfortunately, in this tutorial, we won't be going over player acceptance and flex match just to keep things simple. I will just quickly note that in the case of player acceptance, the potential match created event is no longer noise and becomes an actionable event, but not a final result event, meaning clients can take action upon them, but they can occur multiple times for a ticket. And believe it or not, even in this case, you still don't have to keep track of more than one event for each ticket simultaneously in DynamoDB. I don't have much time to talk about player acceptance scenarios in this video, but I'm always happy to discuss architecture and game design decisions regarding games that require match acceptance from their clients, whether it be on our Discord server or in the comment section below. And the link to this forum post will be in the description below. Alright, now that we have cleared up the confusion from the last part of the tutorial, let's go back to the main topic of this part of the tutorial, which is Amazon Cognito. So what is Amazon Cognito? Cognito is an AWS service that provides authentication, authorization, and user management for applications. Cognito consists of two main components. The first one is user pools, which are described as user directories that you can manage. Manage in this case means handling sign up and sign in through either the Cognito identity provider or an external identity provider like Google, Facebook, Amazon, or Apple. You can also use user pools for managing groups of users within your directory as well. The other component is identity pools, which assume that there is already a user directory that the clients authenticate themselves through. The directory could be with any identity provider, even the Cognito identity provider. Identity pools are responsible for assigning IAM roles to users from other directories, granting different users different access control permissions to different AWS services and resources. The main difference is that user pools are primarily meant for authentication, while identity pools are primarily meant for authorization. And although you can use both user pools and identity pools together, to make this tutorial simpler, we will only be using user pools. If you want more information about the differences between user pools and identity pools, we will have a link in the description below to an article detailing those differences. So then you may be asking, how are we going to handle authorization without identity pools? Because we are using a client service, we are not authorizing the clients, rather we are going to be authorizing the client service, the APIs that the clients will call. However, these APIs will require authentication from the clients to prove, in this case, that they are a uniquely identifiable user within the Cognito user pool that we are about to make. But what separates this approach from using identity pools is that the Lambda function called by the API instead of the user is what is authorized by an IAM role to access specific AWS resources. On the other hand, with identity pools, the client would authenticate itself to the identity pool, and upon successful authentication, the identity pool would grant temporary AWS credentials that can be used by clients to access whatever services and resources they have access to according to the IAM role assigned to the user they authenticated as. In our case, without identity pools, the client just has access to call an authorized API, but the request will not be successful if the client can't properly authenticate itself to the API. This is not necessarily always the best approach depending on your use case, but it is one of the common approaches outlined in Amazon's documentation, which we will have a link to in the description below so that you can see all the common Cognito scenarios. But I do prefer this approach because I like to configure what the client can possibly do through Lambda as opposed to an IAM role, since I have personally found that there is more flexibility through a Lambda function. Regardless, I definitely still encourage you guys to try out the other ways you can do authentication and authorization through Cognito when you guys have time. With that said, let's go ahead and make the Cognito user pool. So sign into the AWS Management Console, type in Cognito in the search bar and select Cognito. From here, click on the button that says Manage User Pools, and then go to the top right and click on the button that says Create a User Pool. For the name, call this pool whatever you want. I'm going to name it GameLift Tutorial User Pool. And once you have a name, click on the button that says Step Through Settings. Now in this tutorial we are going to just stick with the default settings, so we won't modify anything, but I still want to go through all the settings that you guys can configure to customize your user pool. So this first section is about attributes. So we have the how you want your users to sign in section. By default, users sign in through username and password, but you can change these settings to also have them sign in with email, phone number, and preferred username along with the password. On the other hand, you can also change your settings to have users sign in and sign up with an email address or phone number as their quote-unquote username. Then we have case insensitivity, which by default is enabled. So when users sign in with their username, it doesn't have to be exactly right case-wise. Next we have the required attributes, which are the attributes that each user in this pool has to have a value for when signing up, in addition to the username and password, which are always required and that can't be changed. Right now by default, each user has to have an email associated with it. Lastly, you can add up to 25 custom attributes to your user pool. There's a lot more to go over about attributes that I will not be talking about in this video, but feel free to check out the link in the description for more information about user pool attributes. And let's go ahead and click on the button that says next step to go to the next step. This section is about policies with regards to passwords and signing up. So here it specifies the requirements for a password when users sign up. By default, passwords have to be at least 8 characters long and have uppercase letters, lowercase letters, special characters, and numbers. A user will not be able to sign up if their password does not meet these requirements. And for allowing users to sign themselves up, by default, users will be able to make their own accounts. The alternative is to have administrators create accounts for users instead. The last setting has to do with how long temporary passwords set by administrators last if they are not used. I believe that this setting isn't even being used because users are signing themselves up in this pool. And let's go to the next section by clicking on next step. This section is about multi-factor authentication, how users can recover their accounts, and which user attributes Cognito will verify when making or recovering an account. Multi-factor authentication, for those who don't know, adds additional security to your application by adding another authentication method besides username and password. You can have either text messages or time-based one-time passwords as second factors when signing in users. Text messages will obviously require the phone attribute to be required and verified. Also, you can further specify whether or not every account requires multi-factor authentication, or let the users themselves decide if they want to turn on multi-factor authentication. By default, there will be no additional factors of authentication beyond username and password. As for account recovery, you can also configure what options the users have when they forget their password. A code will generally be sent when users want to reset their password, and that code has to be used in order for users to change their passwords. You can decide whether that code gets sent to the user's email or phone. By default, the code will be sent to the user's email. And next up, by default, the email attribute will be verified to confirm an account's ownership when signing up and recovering forgotten passwords. However, you can also change the setting to use the phone number attribute instead. Lastly, if you do end up having Cognito to send text messages to users, you will have to give Cognito permissions to do so by adding a role. Click on next step to go to the next section. This section is about how Cognito will verify users' email addresses when users make accounts. By default, Cognito will send an email to the email address used to make the account, and that email will contain a verification code that you have to use to verify your email address when signing up. On this page, you can customize certain things like whether or not you want to send emails from a SES, which stands for Simple Email Service, Verified Identity. For a production application, you should definitely set up an SES identity and use that for the settings on this page instead of the default No Use Cognito option under where it says do you want to send emails through your Amazon SES configuration, because the default Cognito option has a daily email limit. So if you have a game with high traffic, then definitely make an SES identity and then choose the Yes option. You can also customize the From and Reply To email addresses that will show up in emails sent by Cognito. You can also choose whether or not you want users to confirm their accounts through a code or a link. And lastly, you can choose how you want to customize your user invitation settings. Let's click on next step to go to the next section. In this section, you can add tags. By default, there are no tags, so let's click on next step. This section is just one setting for whether or not you want Cognito to remember your user's devices. You can either have Cognito always remember each device that a user signs in with, or have users opt into this setting. By default, Cognito will not keep track of different devices that users use to sign in with. Let's click on next step. This section is for adding app clients that will be able to access your user pool. Eventually, we will come back to this setting later so that we can add an app client for our Cognito hosted UI application that will have all the sign in, sign up, and forget password features, but for now, just click on next step. This section is about triggers, so basically you can have Lambda functions be invoked when certain events happen, such as pre-sign-up, pre-authentication, post-authentication, post-confirmation, and etc. We will actually come back to this section later, but for now scroll down and click on next step. This is the final section before you create your user pool. This is simply for reviewing your settings, double checking if everything is what you want it to be. If something doesn't look right, you can always go back and modify any one of these sections by clicking the pencil icon on the top right corner of each box. One thing I forgot to mention earlier, the attributes section. This can't be modified after making the user pool, so make sure that if you are making a pool for a production application, that these settings for the attributes are exactly how you want them to be before creating this pool. If everything looks good, just scroll down and click Create Pool. We now have a user pool, but there's one more thing we have to do before we can enable that Cognito website, and that is a callback URL for the Cognito authorization server to call after users are authenticated. So let's quickly make our own callback URL. This will require a Lambda function and an API for that Lambda function. So first, let's make the Lambda function by going to Services, type out Lambda, and click on Lambda. From here, click on Create Function. Make sure author from scratch is selected. For the function name, we are going to call this Lambda function. For the callback URL, get sign in result. Make sure Node.js is selected for the runtime and click on create function. Because this will be a fairly simple function, we will not need any node modules, therefore we won't need a Lambda layer for this function, so we can scroll down and start coding. Get rid of the sample code that is already in the function. Just some quick background before we get started here. This function will get called by Cognito after a user has signed in, whether it is through the Cognito identity provider or an external provider like Google. Usually if Cognito calls this function, then that means the user sign-in attempt was successful, meaning that the user inputted the right username or email and password. Later in this tutorial, I'm going to show you guys how to make it so that each specific email address can only have at most one entry in the Cognito user pool, thereby preventing multiple users per email address. If users are signing in through Cognito, then whenever this Lambda function gets called, it almost always means that the sign-in attempt was successful, because multiple accounts per email will be prevented at the sign-up stage separately. On the other hand, when you use another social provider like Google, the sign-in option will perform a sign-up operation before the sign-in attempt, if that is the user's first time logging in with Google with that email, even if the user already has a Cognito account with that same Gmail address. We will, again later in this video, write code to prevent duplicate user entries in the pool, so that sign-up attempt through Google could fail. Thereby the sign-in attempt will fail, and Cognito will pass certain query parameters when calling the callback URL. I know this sounds confusing right now, but it will make a lot more sense when we test the login website. Let's get started and zoom in. So again, click on Control plus a few times here. And then let's make a local variable that will represent the state of the sign-in attempt and call it response. Then let's actually parse those query parameters we just talked about to see if the sign-in attempt was successful or not. First, we have to make sure they even exist by typing out if, in parentheses, event.queryString parameters, squiggly bracket. And if they do exist, let's make a variable called query and set that equal to event.queryString parameters. Then let's check if one of the query parameters passed to the URL was called error by typing out if parentheses query.error, squiggly bracket, and if query.error exists, then let's return a negative response to indicate that the sign-in attempt was not successful. So let's set response equal to squiggly bracket status code :400, comma body query dot error underscore description. And I'll add a semicolon here. Now normally if an error query parameter was passed to the URL, then an error description query parameter was also passed, and of course return the response. If there were no error query parameters passed to the callback URL, then that means the sign-in attempt was indeed successful. So in that case, let's return a positive response by setting response equal to squiggly bracket status code colon 200 comma body colon in quotes sign-in successful. And then of course let's return the response. Now that we are finished writing this function, click on the save button to save your work. The code and test events for this, along with all the other Lambda functions we code, will be in the description below. Let's go to API Gateway now to make an API for this Lambda function so that we can actually have a URL to call this function from. So go to Services, type out API Gateway, and select API Gateway. So before I move on, let me just quickly go over what API Gateway is and the different kinds of APIs that you guys can make with API Gateway. API Gateway is an AWS service for creating, publishing, maintaining, monitoring, and securing REST, HTTP, and WebSocket APIs. Let's actually scroll down and start at the bottom with REST APIs. REST, for those who don't know, stands for Representational State Transfer, which is a software architecture style that defines a set of constraints that most web services today adhere to. These conforming web services are better known as RESTful web services. According to the REST architecture, a web resource, which is just any entity that can be handled on the web, should be identifiable by some kind of uniform resource identifier, the most common form being the URL. And when requests are made to a resource via their unique identifier, a response containing a formatted payload will be elicited, confirming or denying the access or manipulation of the resource. The architecture does restrict the type of request that can be made to a uniform and predefined set of stateless operations. Stateless just means, in this case, no session information is retained by the server during client-server communication. Therefore, each request made by the client to the server should be able to be understood and performed in isolation, without the context of previous requests made by that same client. The most common stateless protocol used with REST is HTTP, which stands for Hypertext Transfer Protocol. The protocol comes with operations such as get, post, put, patch, and delete, for example. The point of the REST architecture is to create web services that are performant, scalable, easy to modify, easy to call, portable, and reliable. API Gateway's REST APIs are just HTTP-based RESTful web services that can be integrated with backend HTTP endpoints, Lambda functions, and other AWS services. In our case, we will integrate the API with Lambda functions, so whenever a client calls our API, API Gateway will send the request to the Lambda function and return the function's response to the client. Just a note that REST APIs here and HTTP APIs up above, which we will get to shortly, both fall under the category of RESTful APIs. And the difference between private and non-private REST APIs is that private APIs enable you to securely expose REST APIs to resources only within certain VPCs, which stands for Virtual Private Cloud, through VPC endpoints. So for example, this private REST API option could be used to make an API that only the server processes in your fleets in GameLift can access. The private API could be used for functions that only the server should have permission to perform, such as updating player stats after a game ends. Unfortunately, in this tutorial, we will not be covering private APIs and virtual private cloud endpoints, but we will have a link to an article in the description below with more information, because I really encourage you guys to read more about this if you have time. Next up is the WebSocket API. A WebSocket API is a collection of WebSocket routes that are integrated with backend HTTP endpoints, Lambda functions, or other AWS services. While RESTful APIs use a request-response model with a client sending a request to a service and the service synchronously sending a response back to the client, WebSocket APIs are bidirectional, so not only can clients send messages to the API, but also the API can send messages back to the client without an explicit request from the client. This is possible because a WebSocket enables a consistent two-way communication channel between the client and the server over a TCP connection. The WebSocket API could be used for scenarios where you need real-time updates and don't want to do complex polling, for instance, matchmaking requests or a chatting system. Sadly, even though we should use WebSocket APIs for the clients to get the latest status on their matchmaking requests, we're just going to do basic polling instead when we get to that point in the tutorial. Polling still works, it's just that it's nowhere near as efficient as WebSockets. The only reason why we won't be using WebSockets in this tutorial is to save time. Because if we did want to have clients connect to a WebSocket API and get live feedback on their matchmaking tickets, then that would also require a DynamoDB stream, another Lambda function, and more C++ code on the Unreal Engine side. If that interests you guys, then we will have links to articles in the description below with more information about this stuff. And if you want to see either an add-on or separate tutorial integrating WebSockets and Unreal Engine, then comment that down below. Lastly, HTTP APIs are very similar to REST APIs, except that HTTP APIs are designed for low latency and cost-effective Lambda proxy and HTTP proxy APIs. Despite lacking a lot of features that REST APIs have, HTTP APIs do have some features that are not in REST APIs, including support for OIDC and OAuth 2.0 authorization, support for CORS, and automatic deployments. For this tutorial, just to keep everything very simple and consistent, we will be working on a single REST API for the various Lambda functions we write throughout the series. And although HTTP APIs are cheaper and faster than REST APIs, HTTP APIs just came out of beta, so they are still relatively new. Consequently, I'm not very familiar with HTTP APIs on API Gateway. If you guys want to be more familiar with HTTP APIs, then check out the description below for some links to documentation with more information. But don't worry, the free tier for API Gateway comes with 1 million HTTP API calls, 1 million REST API calls, 1 million WebSocket API message transfers, and 750,000 connection minutes per month for the first 12 months upon signing up for an AWS account. So that should be plenty for you guys watching. In reality, for a production application, you would probably use a combination of all 4 API options for practical reasons. For instance, HTTP APIs and REST APIs should be called by the clients. Ideally, you would try to create as many HTTP APIs as possible in order to save money and improve performance, while creating REST APIs only when you need the REST API features that HTTP APIs don't offer on API Gateway. WebSocket APIs would also mainly be called by the clients for things requiring real-time updates, such as getting matchmaking status updates or implementing an online chat system, for example. Lastly, private REST APIs should only be accessible by server processes for tasks such as updating player stats after a game is over, for instance. Finally, I know that an API may seem overkill for a callback URL, but we will be adding more functions to this API for our client service in a future part of the tutorial. So after all that talk, let's go ahead and create a REST API by clicking on the Build button. You may be prompted with this pop-up that says create your first API. Just click on OK to close it. For the protocol, make sure you have REST selected. It should be selected by default. Then under where it says create a new API, click on the checkbox by where it says new API. Under settings, in the text box by where it says API name, we can call the API anything we want to, but I'm going to call it GameLift Tutorial API. The description field is optional, so we'll leave that blank. For the endpoint type, you have 3 options. The first one is regional, and regional APIs are intended for clients in the same region as where the API is deployed. The second one is edge optimized, and edge optimized APIs are deployed to the CloudFront network and are best suited for geographically distributed clients. Because when a request is made to an edge optimized API, the request will be routed to the nearest CloudFront point of presence. The third and last option is private, and private APIs are only accessible from your Amazon Virtual Private Cloud using an interface VPC endpoint, like how we talked about earlier. For this tutorial, we will stick to the default regional option. Edge optimized is also a valid option. I am not knowledgeable enough in API endpoints to recommend one over the other, but keep in mind that regional APIs can be modified to better serve a more geographically diverse client base by using an AWS Route 53 latency-based routing policy or setting up your own custom CloudFront distribution. So if you do end up serving clients from around the world, just note that even then, both regional and edge optimized are still valid options for this endpoint type field. And once again, there will be links in the description below with more information about this subject. So once we're done here, let's go ahead and create our API by clicking on Create API. And on this page, let's proceed to add a resource for our callback URL by clicking on Actions and select Create Resource. We won't be configuring this resource as a proxy resource, so leave that box checked off. For the resource name field, we can name the resource whatever we want to, but I'm going to name this after our Lambda function, which was called getSignInResult. And we will not be enabling API Gateway cores, so leave that unchecked and click the button that says Create Resource. Now while your resource is selected, let's add a method to this resource by clicking on Actions, but this time select Create Method. You should then see a drop-down menu appear under your resource, and if you click on this drop-down menu, you will see a list of various HTTP request method options that you can select from. For our callback URL, we will make a method of type GET, so select GET, and then click the check mark. You should now see a setup page for your new method. For the integration type, make sure you have Lambda function selected if it is not already selected by default. By where it says Use Lambda Proxy Integration, make sure the checkbox is checked. Then make sure you are using the region you are operating in for the Lambda region field. In my case, it's US East 1. Next, in the Lambda function field, start typing out the name of your Lambda function, so in our case, it's getSignInResult. You could have typed the whole name out like I just did, or you could have selected it from the drop-down menu that appeared momentarily as I was typing the name. Leave the Use Default Timeout checkbox checked, and click on Save on the right side of the page, and then click on OK. So we have an API with a resource and a method for that resource that invokes our getSignInResult Lambda function, but we still have to actually deploy this API so that we have a URL from which Cognito can call this method. So to do that, let's click on Actions, click on Deploy API under where it says API Actions, and then for the deployment stage, select that drop-down menu and select New Stage. And then for the stage name, let's just call this test, even though we can name it whatever we want to. For the descriptions, just leave those fields blank since they're optional, and then click on Deploy. So a couple things just happened. One, we made a stage, which is a named reference to an API deployment. The purpose of stages is so that you can have multiple concurrent versions of your API, each with their own URL and configuration settings. In this tutorial, we will have only one snapshot of the API, so we won't have multiple stages, but just keep in mind that you could if you wanted to. And two, you can now see the URL of our API in this blue box up here. If we want the exact route of our getSignInResult method, then on the left side here under where it says stages, click on the arrow by the test stage to expand it, and click on the actual method under the resource, so where it says get down here. The blue box will now have the actual URL of the API's getSignInResult resources get method. We can even click on it to invoke the method, and notice how the sign in successful message appears on the screen. That's because no error query parameter was passed through the URL, so a response with status 200 was returned. If we add an error parameter to the end of the URL by typing out $error equal test, note that the value doesn't really matter here, and press enter, you will notice that the web page won't even load because a response of status 400 was returned. As our APIs get more complex, we will eventually need a more advanced way of testing them. I would suggest a tool called Postman. Link to this download page will be in the description below. Once you are here, hover over the download button in the middle of the screen, and assuming you are on a Windows 64-bit computer, select Windows 64-bit. Once the download is finished, proceed to start the installer. After Postman has finished installing, you may be prompted to sign in, set up your preferences, and once that's all done, you should see this window. So let's go ahead and make a request so that we can test our API in Postman by clicking on New on the top left here, then select Request. For the name, let's just name this after the Lambda function, so getSignInResult. The request description is optional, so we'll leave that blank. And for our request, we will need what is called a collection in Postman, which is just a folder that can help group a bunch of requests. So let's make a new collection by clicking on Create Collection, and we will name this collection GameLift Tutorial Collection. And then click on this check mark to create the collection. and then click on Save to GameLift Tutorial Collection on the bottom right here. For this newly made request, let's set the request URL by going back to that page from earlier, copy the URL, and paste it into this field in Postman, and then press send to invoke the URL. And as we saw earlier, a response of status 400 was sent, but if we get rid of the error query parameter in the URL and press send again, you'll notice that this time you will get the sign in successful message. And since everything looks good here, let's press Ctrl S to save. We have everything we need to create the Cognito login website, better known as the Cognito hosted UI. So copy this URL up here because we will need it for later, and go back to the Cognito console. From here, click on Manage User Pools, select your user pool. In our case, it's called GameLift Tutorial User Pool. And then on the left side here, under where it says General Settings, click on App Clients. Now you should see a button that says Add an App Client. Go ahead and click on that button. An app client is basically an entity within a user pool that has permission to call unauthenticated APIs. These APIs are generally for registering new users, signing in, and handling forgotten passwords. To call these APIs, you need an app client ID and an optional client secret. In our case, the client ID will be passed to a built-in web page for handling the functionalities we just mentioned. Also, the client ID will be used later on in the tutorial series to generate and refresh temporary AWS credentials. Moving on, for the app client name field, you can call the client whatever you want to, but I'm going to call this app client GameLift Tutorial Client. For the refresh token expiration field, we are going to leave that to be defaulted at 30. What this value signifies is that any refresh token generated with this app client's ID for this user pool is valid for up to 30 days from when it was generated, unless the refresh token was manually invalidated through an AWS SDK Cognito function call. While the refresh token is valid, you can use it to generate new access tokens or ID tokens for this user pool. Next up is the Generate Client Secret checkbox. We are actually going to uncheck this checkbox because client secrets are used by applications that have a server-side component. Since our project will be serverless, there is no need for this user pool app client to have a secret. Client secrets are not meant for public applications. We are going to be using the Cognito built-in web-hosted UI, which is public, meaning that it's a website that anyone can access on their web browser if they have the URL. And there's nothing wrong with that. Most websites make you sign in or sign up through a public page. Client secrets are meant for private applications. For example, web server apps or an app that is not public facing. In those cases, the secret would be used to authenticate app clients to an authorization server. And like the name entails, these client app secrets should be kept secret and stored securely. For those who may be wondering why app client secrets are supposed to be kept secret or hidden, whereas app client IDs are generally public, although it is true that attackers can use client IDs to spam and brute force sign-in and sign-up attempts, this is a problem that any public web app with users encounters, but it's up to you to defend your application against those kinds of attacks by implementing a variety of solutions, such as multi-factor authentication, CAPTCHA tests to distinguish between humans and machines, locking devices after too many failed login attempts, and etc. We won't go over how to better secure your Cognito user pool in this tutorial because these scenarios are unlikely. However, I still wanted to point out these kinds of scenarios just in case you guys watching find them interesting. As for the authentication flows configuration below, we are not going to touch any of these settings and just stick with the default values. If you are curious to learn more about each authentication flow, then I highly recommend clicking on this Learn More button by each authentication flow to learn more about that specific authentication flow. Lastly, leave Prevent User Existence Errors enabled. Again, for this option, I would highly advise clicking on the Learn More button to learn more about exactly what it means to enable this setting. And that's it. Let's go ahead and click on Create App Client to create our app client. Once your app client is made, you should see your app client ID under the name of your app client. Now go back to the left side under App Integration and select App Client Settings. Here we are going to configure the settings for the app client that we just made so that we can finish generating that Cognito website that will handle our sign in and sign up functionality. First, click on the checkbox by where it says Cognito user pool under where it says enabled identity providers. This allows users to sign in through the Cognito identity provider. Then for the callback URL, let's paste that URL that we copied earlier. Remember, this is the API endpoint for that Lambda function we just made called getSignInResult. And again, this is the URL that the user will be redirected to after a successful sign-in. The signout URL is where the user will be redirected to after signing out. This is optional, so keep that field blank. Let's scroll down to the OAuth 2.0 section, and under where it says allowed OAuth flows, we are presented 3 different options for how the client will get Cognito user pool tokens. In this tutorial series, we will be using the authorization code grant flow, so check the checkbox by where it says that. Essentially, in the authorization code grant flow, after a user successfully authenticates themselves with one of the enabled identity providers in our app client, the client will receive a authorization code, and this authorization code can be exchanged for a set of Cognito user pool tokens, including an ID token, an access token, and a refresh token. This exchange would happen by making requests to what is called the token endpoint. The next option is called the implicit grant flow, which basically gives the tokens to the user directly through the web browser after successfully authenticating themselves. The implicit code grant flow doesn't require that extra step to get those tokens. However, the client can't get a refresh token through this flow, only an access token and an ID token. Besides the lack of a refresh token, the main reason we are not using the implicit grant flow is actually that when the tokens are directly exposed to the end user, the more likely they are to be compromised, spoofed, or tampered with. And the last option is called client credentials, which is only used in machine-to-machine communication. This flow is used when the application is requesting tokens on its own behalf, not on behalf of a user. In this authentication flow, an app makes a request to the token endpoint, but this time no ID nor refresh token is returned, only an access token is returned. Leave this option unchecked as well. Next, we have the allowed OAuth scopes. OAuth scopes specify the access privileges that come with an access token. We are actually going to go ahead and select all of these scopes. The phone and email scopes grant access to the phone number and email user pool attributes. The OpenID scope grants access to the ID token. The aws.cognito.signin.user.admin scope grants access to the AWS Cognito API operations that require access tokens, and the profile scope grants access to all the other user pool attributes. You don't necessarily need to select all of these scopes. You technically only need at least one scope selected. However, keep in mind that the email, phone, and profile scopes require the OpenID scope to be enabled, considering that the email, phone, and profile attributes come with the ID token. Those user pool attributes are sometimes considered sensitive data, so I do see cases where people disable the OpenID scope. I also see cases where people disable the aws.cognito.signin.user.admin scope because they don't want access tokens to be able to be used to call Cognito API functions. The only reason why I selected all of these scopes is that I'm not sure what your guys' use cases may be, so to begin with, we are going to include more than what we need, and you guys can always come back and modify these app client settings as many times as you want to. A better way to highlight why scopes can be useful is if you define your own custom scopes. These scopes would be customized based on specific resources. For example, you can define different scopes for different access privileges such as read, write, delete, and etc. for a specific resource server. Later in this tutorial, we will make a custom scope for accessing specific API endpoints, but for now, let's go ahead and click on the Save Changes button. The last thing we have to do before we can view our Cognito hosted UI is configuring a domain name for the website. To do that, go to the left side under where it says App Integration and select Domain Name. For the domain prefix, just type out whatever you want. I'm going to type GameLift tutorial For my domain prefix, you guys are most likely going to have to use something different for your domain prefix because your domain has to be available. Once you have something typed out, click on the check availability button on the right. Also note that you can use your own custom domain by clicking on this use your domain button, but we will not be doing that in this tutorial. If it says up here that your domain is available, just go ahead and click on save changes. Now if you go back to the app client settings, you will notice down here that there is now a button called launch hosted UI. So go ahead and click on that. And if you see what I see right now, then that means you have configured your app client and domain name correctly. What you are seeing right now is the hosted UI for your app client. With this web page, users can sign in and sign up through the Cognito identity provider. But before we test this, we still have to do a few things because we are not completely done with this UI yet. Like I mentioned before, we are going to create a custom scope for our app client. Next, we are going to integrate a third-party identity provider, Google, with this custom authentication website. And finally, we are going to add Lambda triggers to our user pool in order to prevent the creation of duplicate accounts per email and initialize player stats upon account creation. So first, let's add a resource server for our custom scope. So to do that, go back to the Cognito user pool page, and on the left side, under where it says app integration, click on where it says resource servers. From here, click on the button that says add a resource server. For the name field, we can call this whatever we want, but I'm going to call it GameLift Tutorial API Server. For the identifier field, again, this can be anything, but I'm going to call it GameLift.tutorial.api. And under where it says scopes, we will define a custom scope for this resource server. And the name for that scope can be anything, but I'm going to name it Access. And since the description is actually required here, I'm going to just write grants access to specific Cognito authorized APIs. Note that you can have multiple scopes for a resource server, but in this tutorial we will have just one, so click on Save Changes to finish defining this resource server. Then let's go back to the app client settings so that we can enable this new scope that we just made, and you will see a new section down here labeled Allowed Custom Scopes. And under that section is a checkbox with text saying GameLift.tutorial.api/access. The format of the custom scope goes identifier/scope. So click on the checkbox to enable our custom scope and click on Save Changes to save our changes. What this basically does is similar to what we wrote in the description for this scope. Now access tokens made through this app client will have access to more resources. In this case, those resources will be APIs. Right now we have a REST API and API gateway. As we add more resources and more methods to that API, we will add a Cognito authorizer to some of those methods, because at some point we will want to restrict who can call specific API endpoints to clients who authenticated themselves through our Cognito user pool. Now let's enable our users to sign in through a social identity provider such as Google. Of course, up here under where it says Enabled Identity Providers, you don't see an option labeled Google. That is because we need to register our app client with Google in order to see and enable that option. To do that, we have to first go to this integrating Google sign-in into your web app web page. Link to this will be in the description below. Make sure that you are signed into a Google account like I am, and then go ahead and click on this Configure a Project button. You can name the project anything you want to, but I'm going to name it GameLift Tutorial Project. And then click on Next. And for the product name, again, you can also name this anything you want to, but I'm going to name it GameLift Tutorial App. And then click on Next again. Then click on this drop-down menu that says where are you calling from, and select web browser. For the authorized JavaScript origin field, go back to the Cognito user pool page, and this time go back to domain name, and then just copy this domain. I know it's going to be weird, but this is copyable, trust me. So just copy that by pressing Ctrl+C, go back to the integrating Google sign-in page, and just paste in that URL, into this authorized JavaScript origin field. Now, the copying may have been a little weird, so just make sure that everything is formatted nicely by getting rid of extra spaces. And then once you have that, click on Create. After that is finished, you should see a screen with a client ID and secret. Just disregard these because we won't be using them. Click on Done to close out of this. And now we will be going to the Google Developers Console. Link to this will be in the description below. Again, make sure that you are signed into a Google account, the same one that you just used to configure that project. You should see up here the name of your project. That means that we are working within the scope of the project we just made. If not, then click on whatever project is selected here. Perhaps you have multiple Google Cloud projects, and from there you can select from a window your project that we just made. Now, if this is the first time that you have accessed the Developers Console on your Google account, you may be prompted to accept some terms and conditions. You don't see that prompt on my screen because I've already accepted those terms and conditions. Moving on to the left side, click on where it says Credentials. On this page, click on the button that says Create Credentials, and this will bring up a drop-down menu. Select OAuth Client ID from this drop-down list, and then choose Web Application for the application type. For the web client, we can name this whatever we want to, but I'm going to name it GameLift Tutorial Web Client. Then for the authorized JavaScript origins field, it's actually going to be the same URL that we used for this field last time when we initially configured the project. So go back to the domain name section of the Cognito user pool settings page, copy this domain name, and of course when you paste the domain name into this field, get rid of any extra spaces. For the authorized redirect URIs field, it's going to be the exact same URL as the authorized JavaScript origin URL, except with some additions. So let's copy that Cognito domain URL, paste it in this field box, and we're going to type at the end /OAuth2/IDP response. Once that's done, click on the Create button. Once the OAuth client is created, do not click the OK button, do not click outside of this window inside this page, and do not exit this page, because this time we will need the client ID and client secret values on this window for later. For now, go back to the Cognito user pool page, and this time under where it says Federation, click on where it says Identity Providers. Since we are using the Google Identity Provider, click on where it says Google, and you'll notice that it'll ask for a Google App ID and a App Secret. So the App ID is pretty much that client ID from earlier. So go back to the Google Developers Console and click the clipboard button by the client ID. And then go back to the user pools page, paste that client ID in the field where it says Google App ID, and then for the app secret below, go back to the credentials page and click the clipboard button by the client secret to copy the client secret, and then go back to the user pools page and paste that value in for the app secret. Lastly, for the authorized scope field, in here you can define the user attributes from the external identity provider, in this case Google, that you want to access with your application. So I'm just going to write for this field profile space email space OpenID. Each value has to be separated by a space in this field. When users sign in through our hosted UI using Google Sign-In, they are giving the Cognito app client consent to access these attributes from the user's Google accounts. In this case, for example, by signing in through Google, users are allowing the Cognito app clients within this user pool to view their Google profiles and emails. By the way, this is just a quick example to just get us running. You can customize the values in this field if you want to grant your Cognito applications access to less or more attributes. But for now, let's enable the Google Social Identity Provider by clicking on this button that says Enable Google. Next up, let's go to where it says Attribute Mapping under where it says Federation. On this page, select the checkbox to the left of where it says Email. And on the right side, you should see a drop-down menu appear. Click on it and select Email. Then click on Save Changes at the bottom of the page. Before we move on, let's explain the reason we did this. You already saw that there was one attribute mapping by default. The Google sub-attribute is linked to the Cognito username attribute. We actually have to map the email attributes between Google and the Cognito user pool because when a user signs in through Google for the first time, a new account in our Cognito user pool is made for that user. And currently, email is the only required attribute in the user pool. Any required attributes in your user pool have to be mapped here between any third-party identity provider that you enable and the Cognito user pool. Otherwise, users won't be able to sign in because accounts can't be made for them in the user pool because the required attributes are missing. Now, if we go back to the app client settings, we should see a new option called Google under where it says enabled identity provider. So go ahead and check the checkbox by where it says Google, scroll down to save your changes, and click on launch hosted UI down here to make sure that you can see a Google sign-in option in your Cognito hosted UI. There are still a couple of things we have to do before testing this authentication website, and that is we have to add what are called Lambda triggers to our Cognito user pool. Lambda triggers are invoked by Amazon Cognito before, after, and while certain lifecycle events happen. These triggers are meant for customizing Cognito workflows. There are so many user pool operations that you can add triggers for. For example, you can have a Lambda function execute before and after users sign up and sign in. You can also have Lambda triggers for customizing authentication challenges like CAPTCHA tests, migrating users from an existing directory to a user pool, customizing verification messages, and more. We won't be going over all the possible Lambda triggers that you can design, but if you are interested in all of the possible user pool workflows and operations that you can set up triggers for, then we will have a link in the description below with more information on that. So let's go to the AWS Lambda page, specifically the functions, and create a new function by clicking on create function. Let's call this function validate duplicate email because this Lambda function will be triggered before Cognito calls the signup operation. Therefore, this Lambda function can accept or deny a signup request. And the reason why we are making this Lambda trigger is to prevent the creation of more than one user in the user pool per email. So go ahead and click create function. Since this Lambda function will be using the AWS SDK, let's add a layer to this function. So select where it says layers and then click on add a layer. And then for this dropdown, select the GameLift tutorial layer that we made earlier. And then for the version, select 1 and click on add. Now that we have a layer, we can scroll down and start coding in the inline editor. So don't forget to zoom in by pressing Ctrl+. And the first thing we are going to do is outside the actual handler function, we are going to include specific modules that we need for this function. So type out const AWS equal require in parentheses in quotes AWS-SDK. Now on the next line, we'll type out const cognito equals new AWS.cognito identity service provider in parentheses and then squiggly brackets. We're going to have one property in this object, which is going to be called region, colon, in quotes, the region that you're operating in. For me, it's US-East-1. Then add a semicolon at the end. Okay, next up we are going to delete the code inside this handler function, and we are first going to check if the event object has properties such as the username and email that the user is trying to sign up with, as well as the user pool ID by typing out if in parentheses event.username $event.userpoolid $event.request $event.request.userattributes $event.request.userattributes.email, and then a pair of squiggly brackets. Inside this if statement, we're going to make a variable for the request parameters that we're going to pass into a call to the Cognito list users function. So let's make a const variable called Cognito request params, and we're going to set that equal to an object with two properties. The first one is going to be called user pool ID, and the value for that property is going to be event.userpoolid. And then the second property is going to be called filter, And the value for this property is going to be in quotes email equal, and then a double quote here. And then after that ending single quote, we're going to have plus event.request.user attributes.email plus single quote, and then double quotes. And we're going to add a semicolon here. Like I said earlier, we're going to pass these parameters to a call to the list users function. So to do that, type out await. And because again, AWS SDK functions are usually asynchronous, so we want to wait until this list users function finishes before we proceed on with the rest of the handler function. And continue typing out cognito.list users in parentheses cognito request params. And then underneath that, we're going to have a .promise, parentheses, .then, in parentheses, data, arrow, squiggly bracket, and then underneath this, we're going to have .catch, in parentheses, error, arrow, squiggly brackets, and then a semicolon. So what exactly are we achieving by calling this list users function? Well, as you can see, we are going to search our user pool directory by its user pool ID for users with a specific email, the email that the user is trying to make an account with. If the call to list users is successful, then we should check if any users were returned. If any users were returned, then theoretically only one user should be returned because we are trying to prevent multiple accounts per email. And if that user's username is not equal to the username that the user is trying to sign up with, then we should throw an error because users should not be able to sign up with more than one account with one email address. So to do that, type out inside this then function, if in parentheses data.users.length greater than 0, double ampersand data.users square bracket 0 dot username dot to lower case parentheses not equal event dot username dot to lowercase parentheses, and then some squiggly brackets at the end here. And we have to throw an error by typing out throw new error in parentheses and in quotes, an account already exists for that email, and then semicolon. And you may be asking, why do we even have to check if the usernames are different? The reason is that Cognito does have some built-in functionality already to prevent multiple accounts with the same username, but Cognito doesn't have built-in functionality to prevent multiple accounts with the same email address, and that's why we are writing this Lambda function. Next, we have to throw an error in the case where the list users function fails. So to do that, type inside this catch function, throw in parentheses error, semicolon. The last thing we have to write at the bottom of the function is return event. And the reason we are returning the event object passed in rather than some kind of custom response is that Cognito's original workflow depends on the properties defined in the event object. And don't forget to save your code by clicking the save button on the top right corner. Now that the code is finished, let's edit the permissions for this Lambda function so that it has access to call the list users function on our user pool. So scroll up, click on permissions, and then under where it says execution role and role name, click on your Lambda function's role, and that'll take you to this IAM page. And then from here, under the permission policies and under the policy name, click on your Lambda function's policy. And then from here, click on edit policy. To edit the policy's JSON document, click on the JSON tab. And then in the statement array here at the bottom after this last statement object, we're going to add a comma and then a pair of squiggly brackets. And then inside this statement object, we're going to type in quotes effect colon in quotes allow, and then comma action in quotes colon in quotes cognito dash idp colon list users, and then comma, and then in quotes resource colon, and then in quotes. This will contain the user pool's ARN value. To get that value, go back to your Cognito user pool, then on the left side, go to where it says general settings and click on that. And then you should see on the right here towards the top a field called pool ARN, and to the right of that should be your user pool's ARN value. So just go ahead and copy that and paste that inside for the resource, and then click on review policy and click on save changes. And that should be it for this Lambda function. If you're not sure about the code, we will have a link in the description below to the code in case you did not quite catch everything, as well as a test event to make sure that the syntax is correct. I am really sorry guys, it has just come to my attention that I made a stupid typo in the Lambda function, so let's go back to Lambda, go back to the configuration tab, scroll down, and up here in line 2, I misspelled identity, so let's just fix that typo. It should be IDENTITY, and then click on save. And we can also use this time to run a test event. As you can see up here, I have already configured one, and the JSON text for this event can be found on GitHub. Just keep in mind for the user pool ID value, replace this text with the user pool ID value from your user pool's general settings, which can be found up here. Obviously no users exist in your user pool yet, so if we go back to the Lambda function and click on the test button to test this event, a successful response should be returned. So if we scroll up here, the execution result was succeeded, and the response returned was, as we expected, the original event that we passed in. The test event at this point is more so just to make sure our function syntax is correct. Okay, everything seems good here, so let's scroll up and click on functions here, because we are going to make another Lambda function that will be triggered this time after a new account is made. So click on create function, and we are going to call this function initialize player data, because after an account is made, we have to keep track of that new user's stats or other game related data. In our case, this data will be in the form of wins and losses, just to keep things simple. This trigger function will write an item in the players table for the new user so that each user in the user pool directory has player data associated with them. Then scenarios like whenever the server needs to update player stats after a match ends, or if the game client wants to retrieve game related information about itself, are now possible after this Lambda function gets triggered. With that said, let's click on create function. But before we actually code this Lambda function, and you may have already guessed it, we don't have a players table for storing player data. So let's go to the DynamoDB dashboard in a separate window and go to the left and click on tables, and let's click on create table. For the table name, we are going to call this table players, and for the primary key we will have a partition key called ID. Leave it as type string, and we will not have a sort key for this table, so leave add sort key unchecked. Make sure that you are using the default settings with auto scaling, and click on create. Once your table is created, that is pretty much it for the table. Note that we are not enabling the time to live attribute for this table because each player item should exist for the lifetime of your game. This table is meant to signify player information and stats, so your game, whether it is the client or the server, will constantly be using player data. Let's go back to the Lambda function now, and since this function will be using the AWS SDK, we have to add a Lambda layer. So click on layers here under the function name, and then underneath where it says layers, again click on add a layer, and then for the name of the layer, just select the layer we've always been using, the GameLift tutorial layer, and the version, same thing, just use version 1, and then click add to add the layer. And once that's done, we can scroll down to the inline editor and press Ctrl+ a few times to zoom in. First thing we have to do is import some modules, so let's do that outside of the handler function and type out const AWS equal require in parentheses and in quotes AWS-SDK, and then on the next line const DynamoDB equal new AWS.DynamoDB in parentheses, and then in squiggly brackets this object will have one property called region, and the value will be in quotes the region you're operating in. For me it's US-East-1, and then a semicolon. Then inside the handler function, let's get rid of the code that's inside, and the first thing we are going to do is check to see if the type of the event that triggered this Lambda function is the post confirmation signup event, because technically, and I could be wrong about this, there are 3 kinds of post confirmation events associated with the post confirmation Cognito trigger. And Cognito groups all of these events together. The 3 events include when a new user has signed up and confirmed its email address successfully on their own, when a new user has signed up successfully with an admin's approval, and when the user has successfully changed their password. And we only care about the case when a new user has signed up successfully without an admin's approval and the new user is confirmed in the user pool directory, because we are not doing any admin stuff in this tutorial. So to do that, let's type out if in parentheses event.trigger source double ampersand event.trigger source double equal in quotes post confirmation underscore confirm sign up, and then at the end some squiggly brackets. If the event's trigger source is post confirmation confirm signup, then let's check to make sure the event request object has the user's Cognito sub ID by typing out if in parentheses event.request double ampersand event.request.user attributes double ampersand event.request.user attributes dot sub, and then some squiggly brackets, and we'll store the sub ID in a const variable called player ID and set that equal to event.request.user-attributes.sub. So what exactly is a Cognito sub ID? When a new user is made in the user pool directory, that user is given a universally unique identifier called sub. It's also known as sub ID and subclaim. The sub value is immutable, meaning that it cannot change after a user is created, which makes the sub ID a perfect candidate for the partition key in the players table. Other candidate values such as the username and email address are unique within our user pool directory. However, these attributes can be changed, whereas the sub ID will never be changed. So let's go ahead and make a variable for the DynamoDB request parameters, and we're going to type out const DynamoDB request params. We're going to set that equal to squiggly brackets, and this object will contain two properties. The first one will be called table name, colon, in quotes, players, comma, and then the second property will be called item, and then colon, in squiggle bracket. This item property will actually be an object, so it's going to contain 3 properties. The first one's going to be called ID, colon, in squiggly brackets. We're going to have s colon player ID, and then the next property is going to be called wins, colon, in squiggly brackets, n colon, in quotes, 0, and then the last property is going to be called losses, colon, in squiggly brackets, n colon, in quotes, 0, and then we'll add a semicolon at the end here. The table name represents the table that we are going to be writing an item to, and the item represents the item that we are writing to the table. And again, I know the wins and losses are technically number attributes, but when writing items to DynamoDB, all the values have to be of type string. So in the track events Lambda function, we use the DynamoDB function called batch write item, because there could be instances where we write multiple items to the matchmaking tickets table. But in this case, we are always going to be writing at most 1 item to the players table for each user. And since this Lambda function only gets triggered for 1 user at a time, we are going to be using the DynamoDB put item function instead. And that's why the request parameters may look a little different than how they looked in the track events function. So let's call put item by typing out await dynamodb.put item in parentheses dynamodb request params, and then underneath that dot promise dot then in parentheses data arrow in squiggly brackets, and then underneath that we'll have a dot catch, and then in parentheses arrow, and then squiggly bracket again, and then a semicolon. Again, this is an AWS SDK function, so it will be asynchronous. That's why we have the await keyword as well as promise, then, and catch. And if the call to put item is successful, we won't do anything, so leave the then function as it is. However, if there is an error when calling put item for whatever reason, then let's throw an error in the catch function by typing out throw and then in parentheses error and then semicolon. And the last thing we are going to add is at the very end of the handler function, type out return event. And again, this is because the original Cognito workflow depends on properties defined in the original event object passed in. So once you have typed all that code out, click on the save button to save your work. Last thing we need to do to finish this Lambda function is modify the permissions policy so that this Lambda function has permission to call put item on the players table. So let's go up, go to permissions, click on the role under where it says execution role and role name. That should take you to this IM page. And from here you can click on the policy under where it says permission policies and policy name. And from here click on edit policy so that we can edit the JSON document for this policy, and further go to the JSON tab. And then inside this statement array, we're going to add, after this last statement object in the array, a comma and then a pair of squiggly brackets. And inside the statement object, we're going to add in quotes effect, colon, in quotes allow, comma, in quotes action, in quotes, in quotes action, colon, in quotes dynamo db, colon, put item, and then comma, in quotes resource, colon, in quotes. We are going to add the resource ARN value of the players table, so go back to DynamoDB, specifically the players table, scroll down and copy to the right of where it says Amazon resource name this value, which should be the ARN of your players table, and then go back to the IM page and paste it here for your resource value. And then click on review policy and click on save changes. Your Lambda function's role should now be modified to give the function permission to write items to the players table through the DynamoDB put item function. Let's just quickly test this by going back to Lambda and configure a test event. This time I'm actually going to configure it in front of you guys in case you guys may have forgotten. So click on select the test event, click on configure test events, and we're going to call this event post confirmation event. And for the actual event itself, we're gonna copy a event from our GitHub repository that has all the Lambda code, including this function that we just wrote, as well as the test cases. Link to this repository will be in the description below. So let's go ahead and copy this test event, and let's go back to Lambda, and we'll just paste it inside this box here, and then click on create, and then click on test. It seems that the execution of the Lambda function with the test event was successful, so let's check out the players table in DynamoDB to see if a new item was written or not. So let's go to the items tab here, and it does look like indeed a new player item was written. Now, since this is just a test event and not an actual user, let's select this checkbox here by the item and go to actions and click on delete, and then click on delete again. We can now finally add our Lambda triggers to the Cognito user pool. So let's go back to the settings for our Cognito user pool and refresh the page so that the page has the latest information about the Lambda functions that we just wrote. And under where it says general settings, go down to where it says triggers and click on that. From here, we are going to add two Lambda triggers. The first one will be the pre-signup trigger. So look for where it says pre-signup, and in that box under where it says Lambda function, click on that drop-down menu and select validate duplicate email. And the second one will be the post confirmation Lambda trigger. So look for where it says post confirmation, and in that box under where it says Lambda function, click on the drop-down menu and select initialize player data. Then save your changes by scrolling down and clicking on the button that says Save Changes. Now let's go ahead and test our Cognito hosted UI. Just to be safe, I know I've had the Cognito hosted UI open for quite some time, but I'm going to close that window and reopen it by going to the app client settings and clicking on Launch Hosted UI down here. Let's first make an account by clicking on the sign up button on the bottom right corner. So I'm going to be making an account first using the Cognito identity provider. For the username, I'm just going to type out, something random. email, just use your email, nothing fancy here. And then password, you'll notice as I start typing in the password, you'll see that there are some built-in Cognito password requirements. So I'm just going to type out a password, and then I'm going to click on sign up. And as part of the normal Cognito workflow, it's Cognito is going to email the email that you use to make that account a code, and you need to use that code here to verify and confirm your account. Before we type the code that was emailed to me, let's go back to the Cognito user pool settings, and under general settings, click on users and groups. The reason that I wanted to do this is to show you guys that a new user was successfully made already, but it has not been confirmed. To show you guys this, click this small refresh button here on the top right corner of the page. And you'll notice there is a new account made for the user that I just tried to sign up for, and its account status, as you can see here, is unconfirmed. And another reason we know this is if we go back to the players table in DynamoDB and click the refresh button, you will notice that no new item was written yet. This makes sense because players can't sign in with an unconfirmed account. So let's go back to the Cognito hosted UI, and let's get that code and paste it inside here and click on confirm account to confirm our account. A few things just happened. So we confirmed our account, and we can verify this by going back to Cognito and refresh our users and groups, and you'll see that the account status has changed to confirmed. And if we go back to the players table in DynamoDB and refresh, you will also see that there is now a player item associated to that new user that was just made. And if we go back to the hosted UI redirected us to the callback URL that we specified earlier in this video. And in this callback URL, a code parameter was passed. Like I mentioned before, this code will be used later in exchange for a set of AWS Cognito user pool tokens. Now let's close this window and relaunch the hosted UI by going back once again to the Cognito user pools app client settings and clicking on launch hosted UI. Let's click on sign in as a different user. This will log us out of the Flopper account that I just made. But this time we're going to sign in through Google to show you guys the differences between signing in through Google and signing in through Cognito. So click on continue with Google, and I'm just going to sign in with my FlopRam Test1 Gmail account. You can just sign in with any one of your Gmail accounts. And once I have signed in, I'll show you guys what this basically did. So like before, you'll notice the callback URL, it has a code parameter. Again, this is another code, but it's used for the same purpose, for getting a set of AWS Cognito user pool tokens in exchange. And if we go back to the Cognito user pools page, specifically the users and groups, and we refresh, you'll notice this time, although a new account was made for that Google account that we just signed in with, the account status is external provider, because unlike signing up through Cognito, you don't directly verify your account through a confirmation code. It's kind of already done for you. And to further prove that, if we go back to the DynamoDB players table and we click on refresh, a new item was still made for that Google account that we just signed in with. And take into account these player ID values. These are the Cognito sub-IDs that we were just talking about earlier. If you want to double check, you can go back to the user pools, users and groups, click on one of the usernames in this pool, and you can see the subclaim right here, and that it was indeed one of the player IDs in the player table. And one last thing about Cognito users, let's go back to the users and groups once again, and let's go back to the users. I just want to show the attribute mapping between the Google Identity Provider and the Cognito Identity Provider. Notice how the username of the account we made through Cognito looks different than the username of the account we made through Google. That is because when we signed up with Cognito, we directly specified a username. When we signed up with Google, we didn't directly specify a username, but we did grant Cognito access to properties within our Google account. So Cognito took the Google account sub-ID and mapped that to its Cognito user's username. Okay, so we have clearly tested the post confirmation Lambda trigger. Let's test the pre-sign up Lambda trigger and make sure that we cannot make more than one account per email address. So let's close the hosted UI window and relaunch the hosted UI once again. From here, let's click on sign in as a different user. Now, just a warning, sometimes clicking on sign in as a different user may not always work when you're signing out of a Google account. If it doesn't work, it may take you back to the callback URL. If that is the case, then you may have to sign out of your Google account, from Google itself. So like you may have to go to google.com and literally sign out of your account from there. But if it does sign you out successfully, then you should see this sign in page once again. And let's click on this sign up button so that we can make an account through Amazon Cognito. And we're just going to try to make a new account with a user with an email that already has an account in the Cognito user pool. So for the username, I'm just going to write this time flopram2. And I'm going to use an email that already has an account. So I'll just use flopram@gmail.com again. And for the password again, just got to meet those requirements. And this time, if you click sign up, you'll notice that this time you'll get an error message pop up saying pre-sign up failed with error, an account already exists for that email. And this is the error message that we define in our Lambda trigger function. Now let's test some built-in Cognito functionality that prevents users in the user pool with the same username, case insensitive. So there's already a user with the username flopram. But even if I try making a new username with that same username but with the M capital, and I use a different email to sign up with, so flopramtest3@gmail.com. And again, for the password, just got to meet the requirements. And I click sign up this time. Now I'll get an error message that says user already exists because there's already a user with the username flopram. The last scenario that I want to check is when signing in with a Google email address that already has a Cognito account for that same email address. So let's click on continue with Google again. But this time let's select an email, a Gmail address that already has an account made through Cognito. So for me, I signed up through Cognito using this flopram@gmail.com email address. So if I try to sign in this time with that same email address, it will take me to the callback URL, but this time I'll get some error parameters in the URL instead of a code because the sign-in operation failed. As you can see, I get that same error message. Pre-sign up failed with error, an account already exists for that email. Now, some people may question this design decision, which is perfectly normal. Again, I just wanted to prevent multiple users in the user pool with the same email address in the most simple way possible for this tutorial. I know it may not be ideal to force each account to only be able to sign in with one identity provider, but I did not want to spend too much time writing a Lambda trigger to handle linking accounts from different identity providers. And if we relaunch the Cognito hosted UI, you will notice again that the sign-in attempt failed because going back to the hosted UI brings you back to the sign-in page instead of that page that we saw earlier that had a button labeled sign in as a different user. So we are now ready to add this hosted UI to our Unreal Engine game client application. To do that, let's open up our Unreal Engine project's Visual Studio solution file in Visual Studio. Once that's opened up, let's go to the Solution Explorer on the right side and find the project's build.cs file and double click it to open it. We're going to add some modules that we will need for the rest of the tutorial. So on this line where it says public dependency module names.add range, at the end of this line, after where it says GameLift server SDK, type out comma, in quotes UMG, comma, in quotes Slate Core. Now, these modules, the UMG and Slate Core modules, are for UI and widgets. Next, type out comma, in quotes HTTP, and the HTTP module is for making HTTP requests. Then type out comma, in quotes JSON, and then in quote, and then comma, and then in quotes JSON utilities. And the JSON and JSON utilities modules are for serializing and deserializing JSON. And lastly, add another comma and then in quotes web browser widget. And the web browser widget is a specific widget that we need for displaying the Cognito hosted UI in our Unreal Engine game client. After adding those modules, make sure you have the development editor solution configuration selected, as well as Win64 for your solution platform. Right click your project and select build. Once the project is finished building, let's open our project in Unreal Engine by double clicking the UE4 project file. Once the project is opened up in the Unreal Engine editor, the first thing we are going to do is create a new level for our game. A level is basically the environment that a player is in. Right now we have one level in this project, but this is the server level. We want to have a main menu level for the client when they first open up the game, before they connect to the server. So let's go to the content browser down here, make sure you're in the third person CPP folder inside the content folder, and open up the maps folder inside. And then here we're going to right click and select level under where it says create basic asset, and we're going to name this level main menu map and press enter. And don't forget to save your changes by going to file, save all. Now double click this new level file that we just made to open the map in the Unreal Engine editor. Because this new level we made is going to be specifically for the client, we have to make a lot of new C++ classes, the main one being a new game mode class. A game mode class does a lot of things. The main thing that we are concerned with is that a game mode class dictates what pawn class, HUD class, player controller class, spectator class, game state class, and player state class that a level uses. And I know that we already have a game mode class called GameLift tutorial game mode, but this level won't be using the same classes we just mentioned as a third person example map. Therefore, we have to make a new game mode class, so to do that, click on this add new button and select new C++ class. From here, scroll down to where it says game mode base, select that, then click on next, and then for the name of this game mode base class, we're going to call this main menu game mode. Again, you can call this whatever you want, and then click on create class. Like I mentioned earlier, the reason we are making a new game mode class is that we want to override some defaults for some classes that we want to use in this main menu level and not in the third person example map level. One of those classes we just talked about is the HUD class. The HUD, which stands for heads up display, is responsible for displaying UI elements on the screen. The player is going to see different widgets on each level. For example, in the main menu level, the player will see a web browser widget for logging in. There is no need for a web browser to be rendered on the screen when the client is connected to the third person example map level on the server. So let's go ahead and create a new class. This time let's look for the HUD class, so scroll down and then select it and then click on next, and we're going to name this HUD C++ class main menu HUD. And again, you can name this whatever you want to, but once you have named it, click on create class. After the HUD class is created, let's go ahead and create another C++ class. Since we just talked about widgets, yes, we are going to make a widget class. For this, we have to look it up in the list of all the available classes, so click on this checkbox by where it says show all classes, and in the search bar type in user widget. And then select this user widget option here, click on next, and we are going to call this user widget class main menu widget. And again, you can call this anything. Once you have that named, click on create class. And believe it or not, we are actually going to create one more C++ class. This class is going to be a general utility class for reading text files. We are making this class because as this tutorial series goes on, you will notice that there will be a lot of API endpoint URLs that we have to use in our Unreal Engine project. For everyone watching, these API URLs will be different, so when this project is on GitHub, I'm going to have a bunch of text files with placeholder text for these API URLs in order to make it easier to clone the final tutorial project and set it up with your guys' API routes. So let's make a new C++ class and scroll down to find where it says actor components, select it, click on next, and we're going to call this text reader component. Then click on create class. After we have made all of our new C++ classes, let's go back to Visual Studio and start with the first class we made. So look for the main menu game mode C++ class in the Solution Explorer and open it up. First, let's include the main menu HUD class by typing out hashtag include in quotes main menu HUD.h. We need a constructor for our game mode class, so go to the main menu game mode header class in the Solution Explorer and type out inside the class definition at the bottom here, public, colon, and then next line a main menu game mode, parentheses, semicolon. And go back to the main menu game mode C++ class, and we can actually start implementing the game mode constructor. So type out a main menu game mode, double colon, a main menu game mode, parentheses, and then a pair of squiggly brackets. Then inside this constructor, let's set the default HUD class for this main menu game mode to be the main menu HUD class by typing out HUD class equal a main menu HUD, double colon, static class, parentheses, semicolon. Next, we are going to edit the main menu HUD class, but because the HUD class relies on the main menu widget, we have to first go back to the Unreal Engine editor and make a new widget blueprint. In this tutorial series, I'm going to keep all the widget blueprints in a folder inside the content folder. So in the content browser, go to the content folder, right click here and select new folder and name this folder UI. And inside this folder, let's make a new folder by right clicking again and selecting new folder again and call this folder widgets. And then inside this folder, right click here and this time hover over user interface and select widget blueprint and call this widget blueprint UI underscore main menu. And then let's save our changes by going to File, Save All. Then open the main menu widget blueprint by double clicking it. And the first thing we are going to do in this widget blueprint is go to File, select Reparent Blueprint, and we are going to look up that main menu widget C++ class that we just made. So look up main menu widget, and then select that widget C++ class. And what reparenting the blueprint does is that now this widget blueprint will inherit variables and functions from the main menu widget C++ class. Although it doesn't seem particularly useful right now since we just made the main menu widget C++ class, as we start adding more and more code to that class, this widget blueprint will inherit that same code. And for testing purposes, we are just going to add a text block widget. So under where it says common in the palette section, just select this text block widget and drag it onto the canvas panel. And then on the right side here in the details section, under where it says content, for the text, let's set that equal to hello world and make sure you press enter after you type out hello world. And then click on save and compile on the top left. Next, let's go back to Visual Studio and edit the main menu HUD class by first opening up the main menu HUD header file. And at the bottom of the class definition, let's first add a constructor by typing out public colon a main menu HUD parentheses, and then let's override the begin play function by typing out protected colon virtual void begin play parentheses override. And finally, let's add a property for a user widget class to construct a widget from and add to the screen by typing out private colon uProperty parentheses and then t subclass of caret user widget caret main menu widget class. Now let's go back to the main menu HUD C++ class and start by adding an include statement at the top here. So let's add hashtag include in quotes blueprint slash user widget dot h. Next, let's implement the constructor. So type out a main menu HUD double colon a main menu HUD parentheses, then a pair of squiggly brackets. And inside this constructor, we are going to get the UI main menu widget blueprints class. So to do that, type out static constructor helpers double colon f class finder, and then in carets user widget, and we're going to call this variable main menu obj, and then in parentheses we're going to pass in text in all caps, and then in parentheses again, and then in quotes we're going to type out the path of the main menu widget blueprint inside our game, where it's located. So in our case, it's located in a folder called widgets, which is in a folder called UI, which is in the content folder. So we're going to type out the path to that, which is going to be /game, not content, /game, /UI, /widgets, sorry about that, made a typo here. So /game, /UI, /widgets, the name of the widget blueprint, which is UI underscore main menu, and semicolon at the end here. And we're going to get the actual class from this main menu obj variable and store it in the main menu widget class property. We're going to set that equal to main menu obj dot class. Now let's implement the begin play function by typing out void a main menu HUD :begin play parentheses squiggly brackets, and the first thing that we are going to do inside here is call the superclass's begin play function, the AHUD parent class's version of begin play. So to do that, type out super :begin play parentheses. Now, by default, the user's mouse cursor won't show up in the game, as you saw in an earlier part of the tutorial series. When you were in the third-person example map, you didn't see your mouse by default, but for a main menu, people are going to have to see their mouse. So let's enable the mouse cursor by getting the player's player controller. So type out a player controller star player controller equal get world parentheses arrow get first player controller parentheses, and then we're going to check if the player controller is a null pointer. So do that by typing out if, and then in parentheses player controller doesn't equal null pointer, and then squiggly brackets. Now if the player controller isn't null, if it exists, then let's set the beam show mouse cursor property of this player controller to true. Just type out player controller arrow b show mouse cursor equal to true. So if there is a player controller at the time of calling this main menu HUD begin play function, then we will get a reference to that player controller and set the show mouse cursor property to true. So when the game loads up, the player should see their mouse cursor in the main menu level. Last thing we are going to do in this class is add an instance of the main menu widget blueprint to the screen. So first, let's perform a null pointer check on the main menu widget class by typing out if in parentheses main menu widget class not equal null pointer, and then a pair of squiggly brackets. Then let's instantiate this widget blueprint by calling the create widget function. So type out user widget star main menu widget and set that equal to create widget, and then in caret user widget, and then in parentheses this function will take in two parameters. The first one will be get world, and then the second parameter will be our widget class, so main menu widget class. And let's do another null check on this instantiation by writing if main menu widget not equal null pointer, and if the widget was created successfully, add it to the viewport by typing out main menu widget arrow add to viewport parentheses, and set the focus to this widget for the owning user so that the user can interact with it. So to do that, let's type out main menu widget arrow set focus. Now, since this widget is the only widget in the HUD, the focus should be set to this widget by default even without calling the set focus function here, but just in case, we're just going to do it manually since I'm not sure if it makes a difference. Maybe you guys in the comment section below can let me know if we need to even set the focus here. So once you've typed out all that code, let's go and rebuild our project. Or not rebuild, because that will rebuild the whole engine, but make sure again you're in development editor configuration as well as Win64 for your platform. Right click your project and select build. After the code is compiled, let's go back to Unreal Engine and go to edit up here and then go to project settings, and on the left side under where it says project, select maps and modes. And we're going to change the default game mode here under the default mode section by clicking on this drop down menu and look up the game mode class that we just made. So it was called main menu game mode, and select the class from the search results. And if we scroll down a little bit to the default map section where it says game default map, we are also going to change the map from third person example map to the new map we just made, which was called main menu map. However, by doing this, we are also setting the default game mode of the third person example map when we change the default game mode under where it says default modes. And we don't want that, since the main menu game mode should only be applied to the main menu level. So let's close out of this and then go to where all the maps are located. For me, it's in the maps folder in the third person CPP folder inside the content folder. Open up the third person example map and go to where it says settings up here on the top. Click on it, and then in this drop down, select world settings. And on the right side here, you should see a new panel titled world settings show up. And under where it says game mode here, for the game mode override, click on this drop down menu that currently says none and find the original game mode class. So for us, it was the GameLift tutorial game mode class. Select that, and then let's go back to the main menu map. And of course, don't forget to save our work. So click on save selected. And note that instead, you could have just overrode the main menu levels game mode and not even touch the third person example map and the project settings. But since there was already a global default server game mode in the project settings, I wanted to treat the non-server default game mode in the project settings as a default client game mode. Again, you could have just set the game mode override for the main menu map, but either way works. Now, if you press play in the main menu level, you should see Hello World, because this level uses the main menu game mode, which uses the main menu HUD, which adds the UI menu widget blueprint to the game's viewport for the player to see. Now, if we stop playing this and we click on X here, I do see this warning. We are going to address it. This widget does not support focus. If this is a user widget, you should set B as focusable to true. We will get to that, but for now, just close out of that. And I just want to show you guys, if we go to the third person example map again and we hit play, you won't see the Hello World text, because again, this uses the GameLift tutorial game mode class. So the GameLift tutorial game mode class doesn't use the main menu HUD, therefore it doesn't ever add a main menu widget to the viewport. So just wanted to show you guys that. So just escape out of there, and we're going to be doing most of our work in this video in the main menu map, so let's go back to it again. Also, I forgot to mention, but you may have already noticed when we were in the project settings, the reason that we changed the game default map as well is that we want client package builds to load up the main menu map, and because we didn't change the server default map, the server package builds will still load up the third person example map. Now, to address the warning we just saw about how the main menu widget does not support focus, there are actually two ways to address that issue. You can either set the isFocusable flag in the blueprint itself, but since the blueprint's parent is the main menu widget C++ class, we can also set the flag there. So let's go back to Visual Studio, find the main menu widget header file, and open it up. We are going to override the native construct method by typing out protected : virtual void native construct parentheses override. Then let's go to the main menu widget C++ class to actually implement that native construct method. So type out void u main menu widget : native construct parentheses and then squiggly brackets. First, we are going to call the superclass the uUserWidget class version of this method by writing super : native construct parentheses, and then set the B isFocusable flag equal to true. Now, I know that many times you usually see flags being set for an object or actor inside a class's constructor. This is normally true, however the widget's UI elements have not been generated yet by the time the constructor is called, in this case. So setting the isFocusable flag to true in the constructor wouldn't do anything because there is technically nothing to be focused on. That's why we are setting the flag in the native construct method, because after the superclass's native construct method is called, all the UI elements in the widget should be made, so now we have something that can be focusable. With that said, make sure again that you have development editor selected for your solution configuration, Win64 for your platform, right click your project and click build. Once the project has finished building, go back to Unreal Engine and play the main menu level again, and then quit out of it by pressing escape. You will notice that the warning about the widget not being focusable does not pop up anymore. That is because we set the widget to be focusable through the widget blueprint's parent, which in this case is the main menu widget C++ class. Okay, so now we are going to modify the main menu widget blueprint, but before that let's enable a plugin. So go to Edit, then Plugins, and in this search bar on the top right, look up Web Space Browser, not one word, otherwise you won't find it, and in the box labeled Web Browser, not Web Browser to native proxying, click on the checkbox by where it says Enabled to enable this plugin, and for the effects to take place in the Unreal Engine editor, click on the Restart Now button to restart your Unreal Engine editor. Once the Unreal Engine editor has restarted, I just want to note that this web browser plugin will only show up in this list if you added the web browser widget module to your project's build file like we did earlier in this tutorial. We are going to need this for our main menu widget, so let's click out of this plugins menu. Let's open up our main menu widget blueprint. Again, mine is located in my UI folders widgets folder, and open it up. And if we expand this window, you can use your scroll bar to zoom in and out. And if we go on the left side here in the palette section, and if we scroll down, you should now see something called experimental. Just expand this list and you should see a web browser. That means that you have successfully added and enabled the web browser widget plugin. Let's actually make this main menu widget serious by deleting that text box we added earlier by selecting it and clicking on delete. And then let's go back to the palette and select the web browser widget and drag it onto the canvas panel. And let's name this web browser widget web browser underscore login. You can name it anything you want, but I'm just going to name it this. And make sure to press enter once you're done typing out the name. Let's then position this web browser widget to take up the entire screen. So in the details section under where it says slot and where it says anchors, select the drop-down menu labeled anchors. Hold down the Control and Shift keys and select this option on the bottom right corner. Now that the web browser widget is resized to take up the entire canvas space, just to test this out, under where it says appearance by where it says initial URL, in this text box field type out the first URL that comes to mind. For me, I'm going to write www.google.com and make sure to press enter after typing out your URL. And then let's save and compile this widget blueprint, and then go back to the main Unreal Engine editor window. Since we restarted Unreal Engine just a little bit ago, let's go and reopen our main menu map and then click the play button to play the level. And this time you should see, as you notice, the web browser widget did take a little time to load, but you should be able to see the Google homepage or whatever website you used for the web browser widget. And you will also notice that you can interact with this web browser. So for example, I can look up here in the search bar Unreal Engine, and I can even press enter and I'll get a bunch of search results related to Unreal Engine. Again, this was just for testing, so let's quit out of this game by pressing escape or click on the stop button here. And let's go back to the main menu widget blueprint and clear out this initial URL field. So delete the text inside, and after deleting this text, make sure to press enter and then click on this save button as well as compile. We are actually going to be setting the initial URL of this web browser widget to point to our Cognito hosted UI. Since the Cognito hosted UI URL will be different for everyone watching this video, we are going to store that URL in a text file, read that in from the main menu widget C++ class, and set the web browser's initial URL in that class. So let's go back to Visual Studio. And the first thing we have to do is write code that gives us the ability to read text files. This is where this text reader component class comes in that we made earlier. So let's go to the text reader component header file. And let's get rid of some of this code that's already here that we don't need. For example, get rid of the begin, play, and tick component functions that are overridden. I'm also going to get rid of this comment above the constructor here. And let's make our own function by typing out uFunction parentheses, and this function will return an f string, and it will be called read file, and this function will take in one parameter of type f string called file path. And let me just get rid of this extra white space here. Now let's go to the text reader component C++ class and get rid of everything inside this uTextReader component constructor, as well as the comment above the constructor. And since we got rid of these begin, play, and tick component functions from the header file, get rid of these functions as well. Before we implement the read file function that we just defined, let's add some include statements at the top of the file. So the first one will be hashtag include in quotes runtime slash core slash public slash misc slash paths.h. And then the next include statement will be hashtag include in quotes runtime slash core slash public slash hal slash platform file manager.h. And then the last include statement will be hashtag include in quotes runtime slash core slash public slash misc slash file helper.h. Now we can implement our read file function. So let's write out underneath the constructor f string utext reader component double colon read file and parentheses f string file path, and then a pair of squiggly brackets. Also, for those people who may be very meticulous or attention to detail oriented, you may have noticed that sometimes for some methods I have the starting squiggly bracket on the same line as the method signature, and then there will be other methods where I have the starting squiggly bracket on the line after the method signature. I will try my best to stay consistent, but just note that it really doesn't matter. You can stick to one style if you want to, but if you don't, then that's okay too. So moving on, in the body of this method, let's get the path of the project's content folder and put that in a f-string variable called directory path, and we're going to set that equal to f paths double colon project content dir parentheses. Now this method will assume that the file path parameter passed in is relative to the content directory. So we are going to make a f-string variable called full path, and this will be the combination of the content directory path and the file path passed in. So let's set this variable equal to directory path plus in quotes slash plus file path. Then let's make a f-string variable called result. This variable will be used to store the text inside whatever file we are reading from. After that, let's make a platform file instance variable. This will be used to check if the file even exists. So let's type out I platform file ampersand file, set that equal to f platform file manager double colon get parentheses dot get platform file parentheses. And to check if the file exists, type out if in parentheses file exists. In parentheses, this function takes in one parameter, and it's going to be star full path, and then we'll add some squiggly brackets. And if the file does exist at the requested location, then let's actually read the file by writing f file helper double colon load file to string. And in parentheses, this function will take in two parameters. The first one will be result, and the second one will be star full path. After this load file to string function gets called, the result variable should have the text inside the file. So let's finish this function by returning the result and build the project. Once your project has been built, let's go to the project directory in File Explorer, open up the content folder, and let's make a new folder called URLs. By right-clicking here, select new and then folder. Again, call this URLs, and then open up this folder, and inside here, click on or right-click, select new again, but this time select text document, and call this text document login URL, and then open this text file up in whatever text editor or program that you prefer, and go back to your Cognito user pool settings, specifically the app client settings, and click on this launch hosted UI button once again, and then take the URL in the web browser, copy it, and then go back to that text file and then just paste in that link inside this text file and save the file. We can then go back to Visual Studio and edit the main menu widget header file so that we can read the URL from the file and actually set the web browser initial URL from the main menu widget C++ class. So let's open up the header file, and let's first define a constructor for our class by typing out public : and then underneath that main menu widget in parentheses const f object initializer ampersand object initializer. The reason why this constructor takes in an object of type f object initializer is that there is no default constructor for objects of type user widget. Any class that does not have an appropriate default constructor will require this constructor definition if you want a constructor for that class. Let's then define a property for the login URL and another one for the web browser widget. So at the bottom of the class definition, let's type out private : and then underneath that uProperty parentheses, and underneath that fstring login URL, and then uProperty again, and then this property will be of type web browser star, and it will be called web browser. Now let's go back to the main menu widget C++ class and add some include statements related to the web browser widget. So the first one will be #include in quotes web browser.h, and then the next include statement will be #include in quotes web browser module.h. Then the next include statement will be #include in quotes I web browser singleton.h. And the last include statement that we are going to add is going to be #include in quotes I web browser cookie manager.h. Also, I just realized, sorry about this, but I forgot in the main menu widget header file to add a for declaration for the uWeb browser class. So let's go back to the header file, and up here type class uWeb browser. Now if you look down in this file, there's no red squiggly text under the uWeb browser pointer property. Heading back to the main menu widget C++ class and moving on to the constructor, this is where we are going to set main menu widget properties such as the login URL. So type main menu widget : main menu widget in parentheses const f object initializer ampersand object initializer, and then super in parentheses object initializer, and then some squiggly brackets. And inside here we are first going to make a variable of type uTextReader component pointer, because we are going to use that read file function that we just coded out in that text reader component class. So to do that, let's type out uTextReader component star text reader, and set that equal to create default subobject in carets uTextReader component, and then in parentheses we're going to pass in a text object that will take in quotes text reader comp, and then we'll close it off with the semicolon. And you will notice that there is some red squiggly text under where it says uTextReader component. That is because we forgot an include statement for the TextReader component header file. So let's add that by going up here and typing hashtag include and then in quotes TextReader component.h. And now we can finally retrieve the URL of the Cognito hosted UI from the text file and set the login URL variable to that value. So let's type out inside the constructor login URL equal TextReader arrow read file in parentheses and then in quotes the path of the text file relative to the content directory. So since the text file is in the URLs folder inside the content folder, we would just type out urls / login URL.text. Again, this is a relative path, not an absolute path. And then just close that off with a semicolon. Next, in the native construct method is where we have to set the web browser property, because again, by the time native construct is called, the UI element should be populated in the main menu widget. So inside this native construct method, let's type out web browser equal in parentheses uWeb browser pointer, and then we're going to type get widget from name, and this is a function that takes in one parameter, which is a text object, and this text object will take in quotes web browser underscore login. And notice that the string that we passed into this get widget from name function is the name of the web browser widget that we set in the main menu widget blueprint. It has to be exactly the way we set it in that blueprint. Otherwise, this main menu widget C++ class will not be able to find that web browser widget. Just gonna add a space here, and now let's write some code related to the 3 other header files that we included in this class. What we are going to do is clear the web browser's cache and cookies every time this main menu widget is constructed. As a result, users will have to sign in every time they start the game client. This may not be the greatest design choice, but it makes things a lot simpler for the tutorial. So to do this, type out iWebBrowser singleton pointer. We're going to call this variable web browser singleton. We're going to set it equal to iWebBrowser module double colon get parentheses dot get singleton parentheses. That line will get us the iWebBrowser module singleton object, and let's just do a quick null check on it by typing out if in parentheses web browser singleton not equal null pointer, and then some squiggly brackets. If the singleton exists, let's make some variables. First one will be of type T optional in carets f string. We're going to call this variable default context, and the second variable will use that default context variable, and it will be of type T shared pointer in carets iWebBrowser cookie manager, and we're going to call this variable cookie manager, and we're going to set it equal to web browser singleton arrow get cookie manager, and in parentheses we're going to pass in that default context variable that we just made. Let's check if this cookie manager is valid by typing out if in parentheses cookie manager dot is valid parentheses and then some squiggly brackets, and if the cookie manager is valid, then let's delete the cookies by typing out cookie manager arrow delete cookies parentheses. And finally, after clearing the web cache and cookies, we can set the web browser widget's initial URL by calling the load URL function. So type out down here web browser arrow load URL, and then in parentheses pass in the login URL. And I know there are a lot of scary looking red squiggly text, but I think that's just IntelliSense glitching out. So once you're done, go ahead and build the project. Once the build has finished, go back to the project in Unreal Engine and click on play so that we can test out the main menu level now, and you should see your Cognito hosted UI. From here we can log in, so I'm just going to log in as Flopram. Again, just log in as whatever user that you made earlier in this tutorial, and you will see this sign in successful message. And if you stop the game and start it up again, you can log in again. So I'm just going to log in again with the same username and password, and you see the sign in successful message again. Because we cleared the cookies, you don't see the page that has a button that says sign in as a different user when you go back to the Cognito hosted UI again. Just want to go over one more thing with regards to Google sign-in. Let's play the game again and log in with Google. And this time I'm going to log in with another Gmail address, so this is just one of my random emails. Then I'm going to type in, see, I can't even type in the password. It's actually going to give us a message saying couldn't sign you in. This browser or app may not be secure. You may have noticed earlier when signing in with a Gmail account in this web browser widget that you got a message that I am seeing right now. I have yet to find out what causes this issue exactly. What I definitely know is that Unreal Engine's web browser widget uses an old version of Chromium. Chromium is an open source project from Google that contains code that can be used to make a web browser. Because Unreal Engine's web browser widget uses an old version of Chromium, it is thereby using an old version of the Google Chrome web browser. And this error is commonly associated with old, not up-to-date web browsers. So the best way to prevent this error is updating the version of Chromium used in the web browser widget. The problem is that this is really hard to do, so we are not going to cover that in this tutorial. However, I have found that when signing into very new Google accounts, for example, made this year in 2020, this error does not occur. On the other hand, I have also seen cases in which people were able to sign into older Google accounts through the web browser widget without encountering any problems. So once again, I don't know the true cause of what you are seeing on the screen right now. Don't worry though, the Cognito sign in, sign up, and forget password features should always work on this web browser widget. So we added and tested the Cognito hosted UI in our Unreal Engine project. What's next is that we have to go back and actually make more Lambda functions, because when we signed into the hosted UI in Unreal Engine, just like how we did it in a normal web browser, the user was redirected to the callback URL. And although you couldn't see it, the callback URL did have a code as one of its query parameters. As we mentioned before, this code can be exchanged for a set of Cognito user pool tokens by calling a Cognito token endpoint. We're going to make a Lambda function to handle this quote-unquote exchange. Then we are also going to write a Lambda function for getting a new access token with the refresh token, and another function for invalidating refresh tokens. Not only are these both important functions that a game should have, but also we can use this as an opportunity to test out Cognito authorizers for our REST API. So let's go to the AWS Management Console, go to Lambda, and then let's create a new function. The first function we are making is going to be for exchanging an authorization code for AWS credentials. So we are going to name this function exchange code for tokens, and then go ahead and create the function. This function will not require any extra node modules, so we don't have to add a Lambda layer, and we can scroll down and get started with the code. Press Ctrl+ a few times to zoom into the inline code editor. Let's first add some node modules that come with Node.js that we need for this function. Outside of the handler function, type out const https and set that equal to require in parentheses and in quotes https. And then let's define another module by typing out const query string and set that equal to require, and then in parentheses and in quotes query string. Let's also define some more variables outside of the handler function. These are going to be variables used for making a request to the Cognito token endpoint, but the values for these variables will be different for everyone watching because these values will come directly from your Cognito user pool. So type out const hostname equal and then in single quotes, and let's go to our Cognito user pool settings, specifically the domain name, and then go ahead and copy your user pool's domain name, and then go back to the Lambda function and then paste it in here. And I know it's gonna paste a little funny, so just get rid of the new line characters and then end that line off with a semicolon. And go ahead and get rid of this https:// here at the beginning of the URL. Let's then make another variable called client ID and set that equal to single quotes. And let's go back to the Cognito user pool settings. This time go to where it says app clients, and where it says app client ID, just copy this value and then go back to Lambda and then paste it in here and end this line off with a semicolon. The last variable we are going to make is going to be called callback URL and set that equal to single quotes, and go back to your Cognito user pool settings again. This time go to the app client settings and copy the value under where it says callback URL, and then go back to Lambda and paste it in for this variable, and once again end the line off with a semicolon. Okay, we can finally start coding in the handler function, so get rid of everything that's already inside this handler function and let's make a few local variables. So type out let response and then let code. Now, requests to this function should contain a body, and that body should contain the authorization code. So let's check if there's a body object in the event object passed to this handler function by typing out if in parentheses event.body and then squiggly brackets, and if there is, let's parse the body, because when we make requests to this function through an API endpoint, the body will be encoded as a JSON string. So type out const body equal json.parse and then in parentheses event.body. And then let's check if that body contains a code by typing out if in parentheses body.code squiggly brackets, and if there is a code, let's set our local variable code equal to body.code. And after this if statement, if it turned out that the request to this function did not have an authorization code in it, then let's return a bad response. So first check if the code doesn't exist by writing if in parentheses exclamation point code and then in squiggly brackets, and we will make the response negative by writing response equals squiggly brackets and then status code colon 400 comma body colon json.stringify and then in parentheses squiggly brackets, and then we're going to write out error colon and then in quotes incoming request did not have a code, and then let's add a semicolon here, and then we will return the response. Now, assuming the request did come with an authorization code, let's start writing some variables that we need for the request that this Lambda function will make to the Cognito token endpoint. So the first one will be called options, and we're going to set that equal to an object with a few properties here. The first one will be called hostname, and this property will be, or this property name will have to be in quotes, because after this colon we're going to type in hostname. When the name of the property is the same as the name of the value, then we have to use quotes to distinguish either the name or the value. In this case, it's going to be the name because we're using a variable. So next up, we're going to have the port, and the value for this property will be 443, and then the next property will be called path, and the value for this property will be in quotes /auth2/token, and then the next property will be called method, and then the value for this will be post in quotes, and then next we're going to have headers, and this will be an object, and this object will have one property called content-type. Now this property name has to be in quotes because there is a hyphen in this name, and the value for this property will be in quotes application/x-www-form-url encoded. When making a request to the Cognito token endpoint, the content type header has to be application/x-www-form-url encoded, not application/JSON or whatever else. And then let's add a semicolon here at the end. The next variable we need for the request will be called token request data, and this will be equal to query string dot stringify, and then this function will take in an object, and this object will have a few properties. The first one will be called code, and the name of this field has to be in quotes because, again, the value for this property will be the variable code. And then the next property will be called grant underscore type, and the value will be in quotes authorization underscore code. And then the next property will be called client underscore ID, and the value for this will be the client ID variable that we define outside the handler function. And then the last property in this object will be called redirect underscore URI, and the value for this will be the callback URL variable that we also define outside the handler function. And then let's just add a semicolon here. Now we can make a promise object for the request to the token endpoint. The reason that we are making a promise is that the request will be asynchronous, and we want to pause this lambda function until the request is finished. So let's type out const cognito token request equal new promise, and then in parentheses we're going to pass in a function, so parentheses again, and type out resolve comma reject, and then arrow, squiggly brackets, and let's add a semicolon at the end here. And in here we will call the https.request function and set it to a variable. To do that, type out const rect, and we're going to set that equal to https.request, and this function will take in two parameters. The first one will be that options variable that we made earlier. The second parameter will be a function, and this function will take in one variable. We're going to call that variable res, and then after the parentheses type out an arrow and then some squiggly brackets, and let's add a semicolon here at the end. And the res variable represents the response from the request to the token endpoint. By default, response data from requests made by the Node.js HTTPS module will be returned as buffer objects, so we have to set the character encoding to UTF-8 in order for the response data to be returned and interpreted as a string in UTF-8 format, which is the standard encoding for JSON. So to do that, type out res.setEncoding, and then in parentheses and in quotes UTF-8. If you didn't set the encoding to UTF-8 and treated the buffer object from the response as a JSON formatted string, you may from time to time encounter errors while trying to parse that object because the direct conversion from buffer to JSON and vice versa can occasionally fail due to the presence of weird characters. Normally, a buffer object returned from the Cognito token endpoint does contain a valid representation of a JSON formatted string, but there have been instances in my experience where that has not been the case. And another point I want to make about this function that we are currently in, this function is a one-time listener for the response event, and we have to add an event listener to the response object for when data arrives. So type out res.on and then in parentheses, in quotes, data, and then comma, in parentheses, data, arrow, squiggly brackets, and when data arrives, we want to return that data not only from this function, but also from this promise. So type out return, resolve, and then in parentheses, data. And then let's add a semicolon here. And that's it for the response event listener. Going back to the function inside the promise, we have to add an event listener for cases where an error occurs while the request is made. So to do that, type rec.on and then in parentheses, in quotes, error, and then comma, in parentheses, error, arrow, and then in squiggly brackets, we have to return the error again, not only out of this function, but also out of the promise. So type out return, reject, and then in parentheses, error, and then add a semicolon here at the end. And we actually have to send the request body, which right now is in a variable called token request data. So to do that, type out rec.write and then in parentheses token request data. And once we do that, we can finish sending the request by writing rec.end parentheses. That should be it for our promise. Now let's write a try catch statement by writing try squiggly bracket and then catch in parentheses error and then squiggly bracket again. And the first thing we are going to do in this try block is actually make the request to the Cognito token endpoint. So write out const Cognito token response and set that equal to await Cognito token request. And again, the await keyword is because the request variable is a promise and we want to make the request to the token endpoint synchronous. If the request was successful, let's make a positive response to return by typing out response equal and then in squiggly bracket status code colon 200 comma body colon Cognito token response. And I forgot to add a semicolon here. The response from the token endpoint will either contain the tokens, including the ID token, the access token, and the refresh token, or the response will contain an error message. Perhaps the code passed in was not valid or it was already used. Note that you can only use the authorization code once to generate a set of AWS tokens. In these cases, an error message saying invalid grant will be returned. If any of the variables outside of the handler function related to the Cognito user pool settings were incorrect, then an error message saying invalid client will be returned. If the request just went wrong for whatever reason, then we will be inside this catch block. And in that case, we should make the response to return negative by typing out response equal squiggly bracket status code colon 400 comma body colon json dot stringify and then in parentheses squiggly brackets error colon in quotes request to OAuth token endpoint failed. And let's just add a semicolon here. And finally, let's finish this function by returning the response. And don't forget to save the function by clicking on this save button. And once again, don't forget that we will have a link to the code in the description below. It's all open sourced on GitHub. You may notice on lines 4 through 6 that the variables outside the handler function are not exactly what they look like in the tutorial and probably in your Lambda function right now. That's because once again, these 3 variables depend on your user pool. So it will be different for everyone, these values. And there are also test events in this same repository for each Lambda function that we write in this tutorial series. So let's run one of these to make sure that the syntax is okay. Let's take this no code event, for example, copy the text inside, go back to Lambda, click on this drop-down menu that says select the test event, click on configure test events. We'll just call this event no code event because this event won't have a code in it. Paste the text inside this gray box and then click on create and then click on test. And you'll notice that this is the expected response. An error was returned and it says incoming request did not have a code. Let's test another event from the GitHub repository. This time let's do the invalid grant event. Again, copy the text inside, go back to Lambda, click on this drop-down menu, select configure test events, and this time click on create new test event. Before it was selected by default because that was the first test event that we made for this Lambda function. For the event name, let's call this invalid grant event. And let's paste that event inside here and then click on create and then click on test. Now, one thing you'll notice from the response return, it actually has a status code of 200. That means if we scroll down in our code here, that means the request to the Cognito token endpoint was successful. But like I said before, sometimes the response returned from the token endpoint can contain an error message inside of it. In this case, the error message is invalid grant because, like I mentioned before, the code that we use in this test event was it wasn't a valid code. You saw it, the code said dummy. So if you want to get an actual set of tokens returned from this Cognito endpoint, then the code passed in has to be a valid code. And you can get a valid code from the Cognito hosted UI. Unfortunately, we haven't gotten to the extraction of the code inside the Unreal Engine Visual Studio Code yet, but we will get there. And once we do, it's up to you if you want to come back to this Lambda function, because we will later, so don't worry. And when we do come back, we'll test this Lambda function with a valid authorization code, and we'll make sure that the response we get back is what it should be, and that it should contain the access token, the ID token, and the refresh token. But as of now, we are done with this Lambda function, so let's go back to functions, and create a new function. The next function we are going to write is for refreshing user pool tokens. Like I mentioned before, a code can be exchanged for 3 tokens: an ID token, an access token, and the refresh token. The ID tokens contain information about the identity of the authenticated user, such as name, email, phone number, etc. The access token contains scopes and groups and is used to grant access to authorized AWS resources. And the refresh token is used to retrieve a new ID token and a new access token. ID tokens and access tokens expire 1 hour after they are generated. Therefore, if people are playing your game for more than an hour in a single session, meaning that they don't quit the client an hour after signing in, then we have to retrieve some new tokens to replace the expired ones. Just a note, by default, refresh tokens themselves do expire after 30 days. So if someone is playing your game for more than 30 days straight in one session, then you will experience an issue trying to obtain new ID and access tokens. But we won't deal with that scenario because it is so unlikely. With that said, let's call this function retrieve new tokens, and then go ahead and create the function. Let's go ahead and add a Lambda layer to this Lambda function, like how we've always been doing it, because this function will rely on functions in the Cognito module in the AWS SDK. And then let's scroll down to the inline code editor and zoom in by pressing Ctrl+ a few times, and let's start by adding some importing the modules we need for this function outside of the handler function by typing out const AWS equal require, and then in parentheses and in quotes AWS-SDK, and then const Cognito equal new AWS.Cognito identity service provider, and then in parentheses and in squiggly brackets there will be one property. It will be called region, and the value for it will be the region code in quotes. For me it's US East 1, just use the region code that you are operating in. Next up, we have to define a variable for the user pool app client ID, so I'm going to define this variable outside the handler function, because again, this will be different for everyone. The value will depend on your user pool. So type out const client ID equal in single quotes, and go back to your Cognito user pool settings, specifically the app client section, and copy the value under where it says app client ID. Go back to Lambda and paste it in here, and then add a semicolon at the end. Inside the handler function, let's get rid of all the code inside here already, and then we'll start by adding 2 local variables. The first one will be called response, and then the second one will be called refresh token. And requests to this Lambda function should contain a refresh token. The token should be passed in through the body, so let's check if the event object passed in has a body object by typing if in parentheses event.body, and then squiggly brackets, and if it does, since the request data will be encoded in JSON, let's parse the body by writing const body equal JSON.parse, and then in parentheses event.body. And inside the body, let's check if there is a refresh token by writing if in parentheses body.refresh token, squiggly brackets, and if there is one, let's set our local variable refresh token equal to the token that was passed in, which in this case is body.refresh token. And of course, after this big if statement, if no refresh token was found, then let's return a negative response. To do that, let's check if there was no refresh token by typing out if in parentheses not refresh token and then squiggly brackets. And if there was no refresh token, set the local response variable equal to something negative. So squiggly bracket status code colon 400 comma body colon JSON not stringify, and then in parentheses and in squiggly brackets error colon and then in quotes incoming request did not have a refresh token. And then let's add a semicolon here, and then return the response. Next, let's make the request parameters that we are going to pass to a call to the Cognito initiate auth function. So let's type out const Cognito request params, set that equal to an object, and this object will contain a few properties. So the first one's going to be called auth flow. The value for this property will be in quotes refresh underscore token underscore auth in all caps. So auth flow is the authentication flow to execute. In this case, the refresh token auth flow will take a valid refresh token and return new tokens. There are other auth flows, but we will not cover those for this tutorial. And since I mentioned that this auth flow will take in a refresh token, the next property is going to be called auth parameters. And the value for this property will be an object, and this object will have one property named refresh token in all caps, and the value for this will be our refresh token variable. And then the last property is going to be called client ID, and the value for this is going to be the app client ID variable that we defined earlier outside of this header handler function. Next, let's make two local variables for the new tokens that we are going to get. So first one will be called new access token, and then the second one will be called new ID token. And we can finally call the initiate auth function. So type out await cognito.initiate auth, and then in parentheses we're going to pass in the Cognito request params, and then underneath that type in .promise .then, and then in parentheses data arrow squiggly brackets, and then underneath that we'll have a .catch, and then in parentheses arrow squiggly brackets, and then a semicolon. Once again, the await, promise, then catch keywords are all there because we want to make this function, this asynchronous function, synchronous. If the call to initiate auth was successful, we should be in this then function. And the initiate auth function in this case should return a data object with an authentication result object inside of it. And that authentication result will have the new token. So let's check if that authentication result object even exists by typing out if in parentheses data double ampersand data dot authentication result squiggly bracket, and then if the authentication result object does exist, let's set those new local variables that we just made to the new tokens that we get from this initiate auth function. So type out new access token equal data dot authentication result dot access token, and then new ID token equal data dot authentication result dot ID token. And let's also make the response that we're going to return a positive response containing the new tokens by writing response equal squiggly bracket status code colon 200 comma body colon JSON dot stringify, and then in parentheses squiggly brackets access token colon new access token comma ID token colon new ID token, and then a parenthesis and then a semicolon. Next, if there was an error while calling this initiate auth function, then that error will be caught in this catch function here. So if that is the case, then let's make the response to return something negative by writing response equal and then in squiggly brackets status code colon 400 comma body colon JSON stringify, and then in squiggly brackets we will have one property called error, and we'll set that equal to error. And lastly, forgot a semicolon here. And lastly, let's finish this function by returning the response. And don't forget to save your changes by clicking the save button. And like we have mentioned before, the code for this function, like for all of the other Lambda functions, will be in a GitHub repository linked in the description below. Keep in mind that on line 4, you have to replace the value for the client ID variable with your Cognito user pool's app client ID. Don't use the same value that I use because that value is for my Cognito user pool. Know that there are also test cases in this same repository. Since we don't have a valid refresh token yet, you can only test the invalid refresh token event and the no refresh token event, just to make sure that the syntax of your function is okay. And I know I mentioned earlier in this part of the tutorial that we haven't written code in our Unreal Engine game client yet to get the authorization code from the callback URL in the web browser widget. However, we can still fully test the two Lambda functions we just wrote by using the Cognito hosted UI in our regular web browser. Let's open up the exchange code for tokens Lambda function in a separate window. And in this drop-down menu, by where it says test, click on it and click on configure test event so that we can create a new test event. Make sure that create a new test event is selected. You may have edit save test events selected by default because maybe you were testing test events from earlier. So again, make sure create new test event is selected. Then go to the GitHub repository with all the Lambda code from this tutorial project, specifically the test events folder for the exchange code for tokens function. Click on the tokens generated event.txt file and copy the text inside. And then go back to the Lambda function, paste it inside here, and then for the where it says insert valid authorization code here, now the authorization code value, we have to go to the Cognito user pool settings, specifically the app client settings, launch the hosted UI, and just sign in either through Google or Cognito. I'm going to use Cognito sign in, so let me just enter my username and password. And I'll click sign in here. And in the callback URL that we were redirected to, take this code parameter up here in the URL. Everything after where it says code equals, just copy it. Go back to the Lambda function, and then again where it says insert valid authorization code here, just replace that with the authorization code that we just copied. So paste it in there. For the event name, again, let's just call it tokens generated event, and then scroll down, click on create to create that event, and then let's test it by clicking the test button. Hopefully the execution result is succeeded, and we can click on where it says detail underneath execution result to see details about the response return, and you should see a valid JSON formatted response containing the tokens as well as some metadata. Do not test again with the same authorization code because a code can only be used to generate a set of tokens once. So if you ran this test event again with the same code, you will get an error response from the token endpoint, and we will need these tokens very soon for when we test the retrieve new tokens function. So do not touch this page. Let's go back to the retrieve new tokens Lambda function and do something very similar. By where it says test, click on this drop down menu, select configure test events. Make sure create new test event is selected, and then go to the GitHub repository with all the Lambda code for this tutorial series, specifically the test folder for the retrieve new tokens function. Go to the valid refresh token event text file, copy the text inside, go back to the retrieve new tokens Lambda function and paste that text inside this text box. And for where it says insert valid refresh token here, we do have a refresh token because when we tested the exchange code for tokens Lambda function, it is in this JSON formatted response return. So let's find the refresh token. It's somewhere here, so you should see refresh token. So let's get everything after it. This may be a little tricky, so be a little careful. So we should have the refresh token selected here. Copy it, go back to the Lambda function, and then for where it says insert valid refresh token here, just replace that by pasting that refresh token value. And then for the event name, let's call this valid refresh token event. And then click on create, and then click on test. Although we can see the response down here, let's scroll up to view the response because I think it's easier to navigate the entire response up here. So click on details again, and let's compare tokens. So this access token in the response should be different than the one generated from the exchange code for tokens function that we just called. So look at your token very briefly. And if we go back to the exchange code for tokens function, I know it's very hard to tell, but if we scroll up and find our access token, so I just found it, it seems to be up here. I know it's very hard to tell, but you can see that they are different. If you don't believe me, you can copy each code and put them both on separate windows of a text comparison tool. This is a random one, but any tool will work. I will have this one linked in the description below. So everything seems to have worked. Just a caveat, retrieving new tokens does not invalidate existing tokens. There is currently, as far as I know, no way to invalidate existing ID and access tokens. So once those types of tokens are made, they will always expire an hour later. And we still have one more Lambda function to make. So let's go back to Lambda, go back to functions, and click on create function. So for this Lambda function, we will be invalidating the Cognito user pool tokens. To do this, we will be calling the Cognito global signout method. And I know I just said that the access and ID tokens cannot be revoked, but I just did some testing off screen, and it seems that the global signout method not only invalidates the refresh token, but also invalidates the access token. I'm not too sure about the ID token. Even though the official documentation for the global signout method says that it only revokes the refresh token, while the access and ID tokens remain valid until their 1 hour expiration date, I am not 100% sure, so we will go ahead and test that later. For now, let's call this function invalidate tokens, assuming that we can invalidate more than just the refresh token, and click on create function. And as usual, since we will be using a function from Cognito, let's add a Lambda layer the same way that we've always been doing it. And of course, just choose the Lambda layer that we've always been using. For me, it's called GameLift tutorial layer, and of course the same version, and click on add. Now we can scroll down and start coding in the inline editor. So inside here, let's zoom in by pressing Ctrl+ a few times, and then the first thing we are going to do is import some modules outside of this handler function. So type out const aws equal require in parentheses and in quotes aws-sdk, and then const cognito equal new aws.cognito identity service provider, and then in parentheses and in squiggly brackets region colon in quotes the code of the region that you're operating in. So again, for me, it will be US-East-1. Next up, inside the handler function, let's get rid of everything inside and make some local variables, one called response and another called access token. Now, because we will eventually add Cognito authorizers to some API endpoints attached to some Lambda functions, for those Cognito authorized API routes, when we call those API methods, in the request we have to specify an authorization header. This authorization header will contain a valid Cognito access token. Otherwise, the request will just get automatically rejected. So when I mentioned much earlier in this tutorial that the access token will grant client applications access to specific resources, those applications, when making requests to specific Cognito authorized APIs, will pass in a valid access token through the request headers. Note that a valid ID token can be used instead of an access token, but in this tutorial, we will be using the access token. Again, all of this is to better secure your APIs by controlling who has access to call those API methods. So let's grab the access token from the authorization headers by first typing out, or really by first checking if there were any headers in the event object passed in by typing out if in parentheses event.headers and then squiggly brackets. And if there are headers, then let's check if there was an authorization header by typing out if in parentheses event.headers and then in square brackets and in quotes authorization, and then squiggly brackets. And if there was an authorization header, then let's set our local access token variable to that authorization header value by typing out access token equal event dot headers in square brackets and in quotes authorization. And as for why I'm suddenly using bracket notation instead of dot notation for accessing properties in an object when authorization, the word, is clearly a valid name that does not require bracket notation, there is no real reason. I've just gotten used to using bracket notation for grabbing the authorization header. I think it's a neat way to say that the access token is kind of a special variable as opposed to like things we've gotten from the event body, since you need a valid access token in the authorization header to even reach this function, but you could have easily done event.headers.authorization instead of event.headers and then square brackets. So if you prefer that, then there is no issue with that. And despite what I just said about how you need an access token to even reach this function, I added if checks anyway just for when you test this Lambda function without API gateway, and I like to overcode sometimes, unfortunately. So next up, let's make the request parameters for the global signout function by making a const variable called Cognito request params and set that equal to an object. And this object will contain one property called access token, and the value for that will be the access token from the authorization header. And then let's add a semicolon. Then let's actually call the global signout method by writing await cognito dot global signout, and then in parentheses we're going to pass in those cognito request params, and underneath that we'll have a dot promise parentheses dot then, and then in parentheses data arrow squiggly brackets, and then underneath that we'll have a dot catch, and then parentheses arrow squiggly brackets, and then another semicolon here. And if we have made it to the then function here, then that means the call to global signout was successful. All the refresh tokens currently out there associated with the user are now revoked, and the user is officially quote-unquote signed out of all devices. We will do a check later to see how this function affects existing and non-expired access tokens, but for now, if we're in here, let's make the response to return positive by typing out response equals squiggly bracket status code colon 200 comma body colon JSON dot stringify, and then in parentheses and then squiggly bracket success colon, and then in quotes user has signed out of Cognito, and then a semicolon. And if something went wrong while calling global signout, then the error will get caught inside this catch function here. And if that does happen, then let's make the response to return negative by typing out response equals squiggly brackets status code colon 400 comma body colon JSON dot stringify, and then in parentheses and in squiggly brackets error colon error. Then we'll add a semicolon, and to end the function, let's return the response. And don't forget to save your changes by clicking the save button. And of course, the code for this function will be in a GitHub repository linked in the description below, which also contains test events for this function. So let's take the invalid access token event, copy the text inside, go back to Lambda, and then click on select the test event, and then select configure test events, and then we'll call this event invalid access token event, and then inside this text box here, let's just paste that text in, and then let's click on create, and then click on test. And if you look at the response that we got back, you'll notice that it was an error and the message was invalid access token, which makes sense because you guys saw the authorization header that we passed in was the word dummy. That's not a valid access token. Okay, now for our last test, we are going to test all three Lambda functions: exchange code for tokens, retrieve new tokens, and invalidate tokens together. So have each function open in a separate window, as well as the Cognito hosted UI. Remember, you can launch this from the Cognito user pools app client settings. And let's first start by logging in. So I'm going to log in through the Cognito provider. So type in your username and password and sign in. And then take this code parameter in the URL and just copy it. Then go to the exchange code for tokens function, specifically the test events. Click on configure test events and make sure you have edit save test event selected, as well as that tokens generated event that we made earlier. And then for the code value, just paste in that value you copied from the callback URL inside the Cognito hosted UI. Click on save, and then let's click on test here so that we can get a new set of tokens. Click on this details button here and try to find your access token inside this huge response here, and let's just go ahead and copy that value. Then go back to the invalidate tokens function, select the test events, click on configure test events, click on create new test events, and we're going to call this event valid access token event, because we actually have a valid access token now from the exchange code for tokens function. You'll notice that it still kept the same JSON formatted text from the invalid access token event, and we'll just replace this dummy inside these quotes here with the access token that we got. Click on create and then click on test to test this test event, and you'll notice that a success response was returned, and the success message was user has signed out of Cognito. Now we know for sure that the refresh token was invalidated, and before we actually go ahead and test that with the retrieve new tokens function, let's actually test the same event with the exact same access token, and let's see if this global signout method actually invalidated the access token as well as the refresh token. You'll actually notice that the access token is indeed revoked. Thank goodness, because we named this function invalidate tokens. You can modify this function if you want to do the same thing to test if the ID token gets revoked from calling global signout, but we're not going to do that for this tutorial. And the last thing we're going to confirm is that the refresh token originally generated from when we just called exchange code for tokens was also invalidated. So let's go back to exchange code for tokens, look for the refresh token in the response. So I just found it, and then let's go ahead and copy that, and then go to the retrieve new tokens function, click on the test events here, then click on configure test events, make sure edit save test events is selected, and for the test event that we're going to select, we're actually not going to use the valid refresh token event here. We're actually going to use the invalid refresh token event, because again, this should be an invalid refresh token now after we just called the invalidate tokens function. So where it says dummy here, let's replace it with that refresh token that we just copied. Click on save and then click on test, and if everything went right, when we click on details here, you should see an error inside the body return, and the message for that error should be refresh token has been revoked. And wow, I know that was a lot, guys, and thanks for sticking through all that Lambda stuff. I know that took a long time, but that should be it for Lambda for a while at least. So let's go ahead to API Gateway now. So go to services up here, let's look up API Gateway, and then click on API Gateway. And here we are going to add routes for these functions that we just made to the REST API that we have been working on so far throughout this tutorial series. So I named the API GameLift tutorial API, so let's just click on the API. From here, click on actions, click on create resource, and we'll call this resource the same name as the function. So I'll start with exchange code for tokens, select create resource, And then make sure that resource is selected and then click actions again, but this time select create method. And then this method I'm going to make of type post because we will be passing in data through the body. Again, my distinction for when I make a method get versus when I make a method post will just be whether or not a body will be passed in through the request. If the answer is yes, then I generally make those methods post. So after you selected post from the drop-down menu, click on this check mark button. Then make sure you have Lambda function selected for your integration type. Make sure the checkbox by where it says use Lambda proxy integration is checked. Make sure for the Lambda region that you have the code for the region for where you are operating selected. For me it's US-E-1. And then for the Lambda function, just type out the name of the Lambda function. So for me it's exchange code for tokens and just select, or if you type out the full name actually, sometimes it'll even autocomplete for you, but generally you can also select the name of the function from the drop-down menu that you saw momentarily. Once that's all done, click on save and then click on OK. Moving on to the next function, make sure this root directory is selected, then click on actions again, select create resource. Again, I'm going to make the name the same name as the function, so this time we'll do retrieve new tokens. And then once that resource is made, make sure it is selected and go to actions again and select create method. And this method, because it does take in a body in the request, we'll make this method of type post. Click on the checkmark button. Make sure Lambda function is selected for the integration type. Again, click the checkbox by where it says use Lambda proxy integration. Make sure it's checked off. Again, use whatever Lambda region you're operating in. And then for the Lambda function, of course, just type out the name of the Lambda function. And then click on save. And then click on OK. And before we move on to the last function, there's actually one more thing we have to do, and this will be the first of many methods that we do this for throughout the tutorial series, which is we are going to add a Cognito authorizer for this method. So anytime someone makes a request to the retrieve new tokens endpoint on this API, they must specify an access token through the request authorization header. I know we specifically mentioned this with the invalidate tokens Lambda function, but this method should also have a Cognito authorizer because I believe if someone or an application is trying to use a refresh token to get new access and ID tokens, then they should have a valid access token currently. This helps enforce the concept that the client should keep a valid, non-expired access token as long as it is running, instead of letting the client just get a new access token whenever it feels like. Later in this part of the tutorial, we are going to have a loop in the game client to retrieve a new access token every 59 minutes. 59 just to be safe, since the token does expire an hour after it is issued. This is just the approach I'm using, so don't feel that you have to use this approach, because I've seen people retrieve new tokens every 30 minutes or even invalidate their access token after one use, retrieve a new token, and then repeat. So there is no right answer here, but let's go ahead and add a Cognito authorizer by first actually creating the authorizer by going to authorizers on the left side here and click on create new authorizer. And we can name this authorizer anything we want to, but I'm going to name it GameLift tutorial authorizer. And then for the type of authorizer, instead of Lambda, make sure you have Cognito selected. And then for the Cognito user pool field, make sure you have the region that you are operating in selected. And once you click on this text field, you should see a list of user pools in that region. Just go ahead and select your user pool. Now, if you have a lot of user pools in your region, then feel free to also type out the name of your user pool. Either way works. And then for the token source field, type out authorization. Basically, the token source field is the name of the header inside the request that you want clients to pass the identity or access token through. For token validation, you can enter a regular expression inside this field so that for each request, the AOD field of the identity token has to be valid before calling the method at the endpoint authorized by this authorizer. Note that if you do use this field, then any access token will be rejected by this authorizer, because access tokens don't have an AUD field inside of them. And since we are using access tokens instead of ID tokens, and this field is optional, we are going to leave this blank and finish creating our authorizer by clicking create. And I know this is going to sound weird, but refresh the page and make sure to do this because this web page is not reactive, so the UI elements on this front end won't pick up the new authorizer you just made unless you refresh the page. Now we can add the authorizer to our method, so go back to the resources on the left here, select where it says post underneath the retrieve new tokens resource, and click on where it says method request up here. And from here, underneath where it says settings, click the pencil button by where it says authorization so that we can add an authorizer to this method by clicking on this drop down menu that says none currently. And underneath where it says Cognito user pool authorizers, select your user pool authorizer and then click on this check button here to update the authorization of this method. And you should see a new field called OAuth scopes appear. Remember that custom scope that we made for our user pool a while back in this part of the tutorial? This is where the custom scope comes in. Because we defined that custom scope, we can use that scope here so that only Cognito user pool access tokens that were generated through that specific app client for the user pool grant you access to this REST API resource. So let's edit this field by clicking the pencil button. And then go back to your user pool settings, specifically the app client settings. Scroll down to find where it says allowed custom scopes, and of course copy the custom scope. There should be only one. If you define more, then pick one of them. Copy it, go back to API Gateway, and then for this field, the OAuth scopes field, just paste it in here. And to save that change, click on the check mark button. And finally, let's add the last Lambda function, so make sure you have the root resource selected, click on actions, select create resource. Again, the resource name, so far the convention I've been following is resource name is the same as the Lambda function name, so I'm going to call this invalidate tokens, and then I'm going to create this resource by clicking create resource. And then make sure you have the method selected, make sure you have the new resource selected, click actions again, but this time select create method. And then in the drop down menu, we're actually going to make this a get method because, and of course click the check mark button, but we're making a get method because we're not really passing in data through the body. In this function, remember we use the access token, but it's going to be passed through the request headers. So for integration type, make sure you have Lambda function selected and make sure you have the checkbox by where it says use Lambda proxy integration checked off as well. And then for the Lambda region, keep that as whatever region that you're operating in. And then for the Lambda function, just type out the name of the Lambda function and then click on save and OK. And like I just mentioned, this function uses an access token passed in through the authorization header. So to strictly enforce that, let's add a Cognito authorizer to this method by clicking where it says method request. And then where it says authorization, click the pencil icon by it. And then in this drop-down menu, select the user pool authorizer and then click this check mark. And then you should see the OAuth scopes field appear again, and then click on the pencil icon by that. And then for the scope, once again, just use the same scope from your Cognito user pool. Luckily, I still have the scope copied to my clipboard. Hopefully you guys do too. If not, just go back to your app client settings and your Cognito user pool settings, copy it, paste it here, and then click the check mark button again. And the REST API should be ready for deployment now. So go to actions, under where it says API actions, select deploy API for the deployment stage. Click on this drop down menu and select the stage that you made earlier in this part of the tutorial. My stage was called test, so select that. Deployment description is optional, so leave that blank and click on the deploy button. And where it says test, just click on this tiny triangle button by it to expand the stage and look over it. Just make sure that the newly deployed API has all the resources and methods that we just added. In my case, everything seems to look good here. Now, before we go back to Unreal Engine, I'm just going to open up Postman. That's a program we downloaded earlier in this tutorial. And we're going to use Postman to make sure that our API routes all work fine in the sense that they point to the right Lambda functions. In here, let's make a new request by clicking this new button on the top left corner, select request, and we are first going to be testing the exchange code for tokens endpoint. So let's call this request exchange code for tokens. Description is optional, so leave that blank. And for the collection, select the collection that we made earlier in this tutorial, and then click on Save to GameLift Tutorial Collection. For the request URL, let's go back to API Gateway, and where it says exchange code for tokens, click on where it says post, and then copy the invoke URL. Go back to Postman, and then where it says enter request URL, paste it in there, and this method is not of type get, so select this drop down menu and select post, and then just click on the send button. You should see a message that says error, incoming request did not have a code, and that's good. Again, we're not testing for functionality here. We already did that in the Lambda console with the test events. We are just testing the mapping of the REST API's resources, making sure that when requests are made to specific endpoints, the right Lambda functions are invoked. If you want to add a body to requests made to this URL, you can select the body tab here and add a code parameter if you want, but we won't do that in this tutorial. Feel free to do it if you have time. Press Ctrl S to save this request, and let's make a new request. And click on request, and for the request name, because we are going to be testing the retrieve new tokens API endpoint now, call this request retrieve new tokens, leave the description blank, and the collection that you use for the exchange code for tokens request should actually be selected for you already, so click on the Save to GameLift Tutorial Collection button. And then for the request URL, go back to API Gateway, and then go to where it says retrieve new tokens. Underneath that, click on post, and then copy where it says, or copy the value to the right of where it says invoke URL. Go back to Postman and paste it in here where it says enter request URL. And this method is not of type get, so click this drop down menu here and select post, and then click on send, and you should see a response of status 401, and that response should also have a message that says unauthorized. This is normal because we didn't specify a valid access token as a authorization header in this request. So we will actually get the same response from the invalidate tokens API endpoint if we don't pass in a valid access token as well. So even though I literally just said that we are not going to test the exchange code for tokens endpoint thoroughly through Postman, I lied, because we need a valid access token to test the mapping of this retrieve new tokens endpoint as well as the invalidate tokens endpoint. So go to your Cognito hosted UI through your app client settings, and let's log in here. I'm just going to log in through the Cognito provider, type in your username and password, sign in, and then get the code from the URL here, copy it, go back to Postman, go to the exchange code for tokens request, make sure you have the body tab selected here, and underneath that select this option labeled raw, and then where it says text, click on that, and you should see a drop down menu with some options here. Make sure you have JSON selected. What this will do is it will set the content type header of this request to application/JSON, and what that does is it will make sure that your request content is encoded in JSON, which is what we want pretty much for almost every request we have in Postman, because all of our Lambda functions assume that the request content is encoded in JSON. So let's actually write out the body of this request. So let's add some squiggly brackets, and then in double quotes, not single quotes, you can't use single quotes here in Postman, type in code and then colon for the value, add another pair of double quotes, and then just paste in that code that we copied earlier from the hosted UI, and then click on the send button, and the response you get back should be a set of Cognito user pool tokens. And you'll also notice some other stuff that you can see clearly now that you couldn't see before when we were in the Lambda console. You also get some metadata about the tokens. For example, When does it expire? This 3600 number is in seconds, so that's 60 minutes, and then the token type, which is bearer. Don't forget to save by pressing Ctrl S and copy this access token in the response. Go back to the retrieve new tokens request, and this time click on where it says headers, and we are going to add a header that is going to be called authorization, and the value for this authorization header will be the access token that we just copied. So paste that inside here and then click on the send button, and you should no longer see message unauthorized returned. And the reason we didn't pass in a refresh token through the request body is because, again, we are just testing the mapping of this API endpoint to the retrieve new tokens Lambda function, because we know that the actual Lambda function itself works from the testing we did earlier. But if you want, you can do what we did for the exchange code for tokens request in Postman. You can go to the body tab if you want and do what we did earlier. Just select raw, then select JSON from the drop down menu, and then write your own request body with a refresh token property and the refresh token from the exchange code for tokens response. Paste it in for that refresh token property inside your request body, and then click send again to make sure the Lambda function works. But we already did that, so we're not going to do that again. And finally, well, first let's press Ctrl S to save, and finally we're going to make the final request in Postman. So click on new again, click on request, and of course this is going to test the invalidate tokens endpoint. So let's type out invalidate tokens. Of course these fields should all be the same, and click on save to GameLift tutorial collection. Then go back to API gateway and select where it says get under where it says invalidate tokens, and copy the invoke URL. Go back to Postman, copy it in for the request URL field, and since this is indeed a get method, we don't have to change anything here. Go back to the retrieve new tokens request and make sure you have the headers tab selected. And a cool thing you can do here is inside this grid, click and hold your mouse inside one of these empty boxes in this grid, and then drag your mouse to the other side of this grid, and then let go of your mouse, and then press Ctrl C to copy this header, and then go back to the invalidate tokens request, go to the headers tab, and then click inside this in this box under where it says key, and then press Ctrl V to paste that header. And now this invalidate tokens request will use this authorization header, which is exactly what we need because this access token is still good, it hasn't expired yet. And let's click on send, and we know the mapping is right because of the response we got back. And that is it for Postman. Press Ctrl S one last time to save this request, and let's close out of here. Now let's add a couple new text files for URLs inside the Unreal Engine project's content folder. And we kept these URLs in a folder called URL, so open that up. And inside here we're going to make two new text files. The first one is going to be called API URL, and the second one is going to be called callback URL. The reason we only made two new text files is that you may have noticed that each API endpoint has the same URL prefix. Basically, for each API route, everything before the name of the resource is exactly the same. So let's open up this API URL text file, and while we're at it, let's actually open up the callback URL text file as well in whatever text editor you prefer. Starting with the API URL, let's go back to API gateway, and on the top left corner here, select the name of your stage. In our case it's called test, and copy this invoke URL. And then let's go back to the API URL text file and paste that API URL inside here. Press Ctrl S to save, and then go back to the callback URL text file. And for this text file, we are going to need the callback URL in our Cognito user pool app client settings. So the reason we made a callback URL text file is because that callback URL will help us parse the URL after a successful sign-in, so that we can extract the code parameter from the URL and pass that in the body of a request to the exchange code for tokens API endpoint. So go to your Cognito user pool settings, again the app client settings, and copy the callback URL and paste it inside this text file and press Ctrl S to save. Now let's proceed to open our Unreal Engine project in the Unreal Engine editor. And let's go ahead and actually create one last C++ class, a game instance class, because when the client gets these Cognito user pool tokens, we have to make sure that those tokens persist as long as the Unreal Engine game application is running. In our case, we only need a valid access token and a valid refresh token while the game is running, whether the user is on the main menu or connected to the server. We will no longer care about keeping these tokens once the user quits out of the application. For all of the reasons just stated, the game instance class is perfect for storing these AWS tokens. And the game instance class is a high-level manager object for an instance of the running game. So none of the data in the game instance is kept after the game application closes. But the game instance is not destroyed when changing levels, and as you will see in the next few parts of the tutorial, the player changes levels when joining and leaving the server. For example, joining the server means going from the main menu map to the third-person example map hosted on one of these server processes on one of the EC2 instances in our GameLift fleet that we made in an earlier part of the tutorial. And leaving the server means going from that third-person example map back to the main menu map. During these level changes, the game instance does not get destroyed. Therefore, if we kept the tokens there, they would not be destroyed either. So let's go ahead and make this class by clicking on where it says add new here and select new C++ class. And then let's look for that game instance class. Actually, for this class, you may have to click on show all classes and actually look up game instance. And then just select game instance here and then click on next. And for the name of this game instance class, let's call this GameLift tutorial game instance and click on create class. Once that class is created, Visual Studio should have automatically opened up for you. Just a note, the reason why we named the game instance class GameLift tutorial game instance instead of main menu game instance is because, as far as I know, an Unreal Engine project can only have one game instance. So this game instance class is not particular to one specific map. It is for the entire project, while the user is in either the main menu level or the third person example level. So the first thing we are going to do, since we are in the game instance class, let's go to the GameLift tutorial game instance header file and add an include statement up here for doing HTTP related stuff. So type out hashtag included and then in quotes runtime/online/http/public/http.h. Next, let's make a constructor for the game instance class. So to do that, type out public : uGameLift tutorial game instance parentheses and then semicolon. And then let's override the uGame instance superclass's shutdown method because, like I mentioned earlier, we no longer need the AWS Cognito tokens to work after the game application shuts down, so we can override the shutdown method to make a request to the invalidate tokens API endpoint, in addition to whatever cleanup is originally being done by the game instance when the program ends. Let's type out virtual void shutdown parentheses override. And then let's define some public properties for the tokens because they will need to be accessed by other classes in this project, like the main menu widget, for example. So type out uProperty parentheses fstring access token, and then uProperty fstring ID token, and lastly uProperty fstring refresh token. Then we need a ftimer handle variable because, like we talked about earlier, we will be calling the retrieve new tokens API endpoint every 55 or so minutes. I know I said the number 59 earlier, but since the access and ID tokens expire 1 hour after they are issued, and I want to try my best to make sure that the application always has a set of valid tokens at all times, I am going to retrieve new tokens every 55 minutes instead of 59 just to be extra safe in case the request to the API endpoint fails for whatever reason. So let's define a ftimer handle property by typing out u property parentheses and then ftimer handle, and let's call this property retrieve new tokens handle. And let's make a function here while we are in the public section of this header file. The function will be for setting the Cognito token properties that we just defined. This function has to be public because this function will be called from other classes as well as the GameLift tutorial game instance class. So type out u function and then void set Cognito tokens, and this void method will take in 3 parameters. The first one will be of type fstring and it will be called access token. The second one will also be of type fstring and will be called ID token, and the last one will also be of type fstring and will be called refresh token. Moving on, let's now define some private variables and functions. So type out private colon, and first we will define a variable of type fHTTP module pointer, not a u property, and it will be called HTTP module. For those wondering, fHTTP module is a Unreal Engine module used for making HTTP requests. Then let's define a fstring variable for the API URL that we are going to retrieve from the text file made earlier. So type out u property parentheses and then fstring API URL. And because we will be calling the retrieve new tokens endpoint on a time interval, we will need to perform this logic in a function that can be binded to what is called a delegate in Unreal Engine. So let's define this function by writing u function parentheses void retrieve new tokens parentheses. And when making HTTP requests in Unreal Engine, you can specify a callback function that gets called after the request is completed. So we are only going to define one for requests made to the retrieve new tokens endpoint, not for requests made to the invalidate tokens endpoint. The reason for that is because after retrieving new tokens, assuming the request was successful, we have to set the game instance token variables to the new ones from the response from the API. But when we call invalidate tokens, this will occur when the game is shutting down, and since HTTP requests are asynchronous, the likelihood of even reaching a callback function for the invalidate tokens API endpoint is very low, meaning when we make a request to that endpoint, the application won't have an opportunity to quote-unquote react to the response returned because the application will most likely not be running anymore by the time the request finishes. So again, let's just define one callback function for retrieve new tokens by typing out void on retrieve new tokens response receive. Note that this is not a u function, and then in parentheses this callback will take 3 parameters. The first one will be of type fHTTP request pointer or PTR, and it will be called request, comma, and then the second parameter will be of type fHTTP response PTR, and it will be called response, comma, and then the last parameter will be of type bool, and it will be called b was successful. And generally, all callback functions for HTTP requests follow this same format. Okay, now let's go to the GameLift tutorial game instance C++ class, and the first thing we're going to do inside here is add some include statements. So first we're going to add some include statements for some JSON related stuff. So type out hashtag include in quotes json.h and then hashtag include in quotes json utilities.h. And of course we're going to also include that text reader component that we made earlier in the tutorial so that we can read the API URL from that text file. So hashtag include in quotes text reader component.h. And then let's make the constructor by typing out u GameLift tutorial game instance double colon u GameLift tutorial game instance and then parentheses and squiggly brackets, and in the constructor let's construct an instance of that uTextReader component class. So let's type out uTextReader component pointer. We'll call this variable text reader and we'll set it equal to create default sub object, and then in carets, u text reader component, and then in parentheses, in this function we'll pass in a variable, a text object variable, and this text will have in parentheses and in quotes text reader com. And then let's end that line off with a semicolon, and then of course let's use this text reader variable to actually get the API URL and set it. So let's set API URL equal to text reader arrow read file, and then in parentheses the path, or in parentheses and in quotes the path of the API URL text file relative to the content folder. So it's going to be urls / API URL.txt. And then lastly, let's instantiate the HTTP module. So let's type out HTTP module equal ampersand HTTP module :get parentheses. Oh, and sorry about that, I made a typo. Let me just fix that. Now let's implement that shutdown method that we overrode from the uGameInstance class by typing out void uGameLift tutorial GameInstance :shutdown, and then parentheses and squiggly brackets. And the first thing we're going to do in this method is call the superclasses shutdown method by typing out super :shutdown parentheses. Note that the shutdown method only gets called when the application ends naturally, not when your Unreal Engine game process gets killed forcefully. For example, if you end your game through Task Manager, then this function won't get called. Just keep that in mind. And like I mentioned earlier, in addition to the normal cleanup stuff that the game instance originally does, we will also make a HTTP request to the invalidate tokens API endpoint so that we can officially quote-unquote sign the user out. So let's first check if the access token length is greater than 0 by writing if in parentheses access token.len is greater than 0 squiggly bracket, and if it is, let's make a HTTP request object by typing t-shared ref, and then in carets HTTP request, and we'll call this variable invalidate tokens request, and we'll set it equal to HTTP module arrow create request. And let's set the URL of this endpoint by typing invalidate tokens request arrow set URL, and then in parentheses let's pass in the route of the invalidate tokens API endpoint, which should be API URL plus in quotes / invalidate tokens. And then let's set the method type of this request to get by typing out invalidate tokens request arrow set verb, and then in parentheses and in quotes get. And I made a typo here. And then let's add 2 headers to this request by typing out invalidate tokens request arrow set header, and then in parentheses this function, the set header function, will take in 2 parameters. So for this one, the first one will be content-type in quotes, and then arrow, or then comma, the second one will be in quotes application/JSON, just like how we did it in Postman. We set the content type header to be application/JSON so that the request content would be encoded in JSON. And then the next header, sorry, I forgot the semicolon, and then the next header, let's type out invalidate tokens request arrow set header again, and 2 parameters. First one will be authorization in quotes, and then comma the access token variable. And this is just like how we did it in Postman again. We also need the access token passing through the authorization header to even get access to the API. And then we can actually send the request by typing out invalidate tokens request arrow process request. Next, let's implement that set Cognito tokens function we defined by typing out void uGameLift tutorial game instance set Cognito tokens, and in parentheses f string new access token, comma f string new ID token, comma f string new refresh token. And squiggly brackets, you may have noticed that the parameter names for this function here are different than the parameter names we used for when we defined the same function in the header file. In C++, the parameter names in the function definition and implementation don't have to be the same. The only reason they are different here is that I can't use the parameter names I used in the header file when setting the game instance's token variables without getting a warning. And like I just said, all we are going to do here is just set the token variables to the parameters passed into the function. So write out access token equal new access token, ID token equal new ID token, and refresh token equal new refresh token. And for now, just for testing purposes, let's write a log statement to print out the actual value of the access token. So to do that, type out UE_log in, made a typo there, UE_log in parentheses, log temp, comma, warning, comma, text, and then in parentheses and in quotes, access token, colon, %S, and then a comma here, and then star access token. And let's set a timer so that the retrieve new tokens function, which will make a request to the retrieve new tokens API endpoint, is called in X number of seconds from now. So to do that, let's type out get world parentheses arrow get timer manager parentheses dot set timer, and this set timer function will take in 6 parameters. So the first one will be the timer handle that we defined earlier, which was called retrieve new tokens handle. And then the second parameter will be this, so this GameLift tutorial game instance object. And then the third parameter will be a pointer or the address of the function that we want to call. So ampersand new GameLift tutorial game instance retrieve new tokens. And then the next parameter will be the rate at which this function will get constantly called, and this value can technically be anything in this case, so I'm just going to make it 1.0f. The reason why it can be anything in this case is because the next parameter is whether or not you want this function to be called on loop. So like right now, because we passed in 1 as the fourth parameter, if we set this function to be called in loop to true, then this function will get called every second, but we don't want to do that, so we're just going to set this to false, and we'll get to why that is later. And then the last parameter is basically the delay until this function is called for the very first time. So for now, just for testing purposes, this will be changed later, but we're going to actually make this 60.0f. So, and then we'll add a semicolon. So this function will be called 60 seconds from when this set Cognito tokens function is called. I know we discussed earlier that we wanted to refresh tokens every 55 minutes, and we will do that, but this is just for testing purposes so that we can see the function getting called and that we are getting new tokens. We just want to see that working because I don't want to make you guys wait an hour just to test this out later. Now let's actually implement this retrieve new tokens function by typing out void uGameLift tutorial game instance retrieve new tokens parentheses and then squiggly brackets. And the first thing we're going to do in here is just make sure that the access token and refresh token lengths are greater than 0. because we don't want to pass in a blank access token or a blank refresh token upon a request to the retrieve new tokens API endpoint. So type out if in parentheses access token dot len parentheses greater than 0 double ampersand refresh token dot len parentheses greater than 0 and squiggly brackets. Unlike the last HTTP request we made, the request to the retrieve new tokens endpoint will require a request body. So let's make an fjson object by typing out t shared ptr and then in carets fjson object, and we'll call this request obj, and we'll set that equal to make shareable and then in parentheses new fjson object. And then we will set a field inside this request object by typing out request obj arrow set string field, and then in parentheses this function will take in two variables, obviously the name of the field as well as the value of the field. So the name of the field, if you remembered, should be in quotes refresh token, and then the value will be the refresh token variable. And let's actually convert this JSON object to a JSON formatted string by making a local variable for that string. So type out fstring request body, and then to do the actual conversion from fjson object to string, first we're going to need a tjson writer object. So type out t shared ref and then in carets tjson writer and then in carets again, and then we'll call this tjson writer variable writer, and we'll set it equal to tjson writer factory caret double colon create, and then in parentheses this create function will take in ampersand request body. To actually do the JSON serialization and store the result into that request body variable that we just made, type out if in parentheses f JSON serializer double colon serialize, and then this function will take in two parameters. The first one will be request obj.to shared ref parentheses, and then the second object will be that writer variable that we just made, and then add a pair of squiggly brackets. And if we have a request body, then let's make an IHTTP request like how we just did it for the invalidate tokens endpoint with a few minor differences. So begin by typing out t shared ref and then in carets IHTTP request, and we'll call this retrieve new tokens request, and we'll set it equal to HTTP module arrow create request. And the first difference will be that for this request, we will set the on process request complete delegate to the on retrieve new tokens response received function that we defined earlier, because unlike the invalidate tokens endpoint, we actually want to handle responses returned from the retrieve new tokens API. So type out retrieve new tokens request arrow on process request complete parentheses dot bind u object, and then this function will take in two parameters. The first one will be this comma, and then the second parameter will be the pointer to or address of the callback function. So ampersand u GameLift to made a typo u GameLift tutorial game instance, made another typo, double colon on retrieve new tokens response received. Let's add a semicolon to the end of this line, and I actually made a token in the last line. Sorry about that, guys. Retrieved is spelled RETRIEVE. And then let's set the URL of this request. So type out retrieve new tokens request arrow set URL, and in parentheses this should be the API route of the retrieve new tokens endpoint. So type out API URL plus in quotes slash retrieve new tokens, and then also the method type of this request will be post, not get. So this time type out retrieve new tokens request, arrow, set verb, and then in parentheses and in quotes, post. And then let's add the exact same two headers that we set before. So retrieve new tokens request, arrow, set header, in parentheses and in quotes, content dash type, and then comma, in quotes again, application slash JSON, and then retrieve new tokens request, arrow, set header, in parentheses and in quotes, authorization, comma, and then the access token variable. Then let's set the request content to the request body string. So type out retrieve new tokens request, arrow, set content as string, and then in parentheses pass in the request body. So when we make this request to the retrieve new tokens endpoint, that request will contain that JSON formatted body string that we just made, that includes the refresh token. So after that, let's actually send the request by typing out retrieve new tokens request, arrow, process request. And if for whatever reason the JSON serialization fails, then let's set the timer again to call this retrieve new tokens function again in, very short amount of time. So let's write else, squiggly brackets, get world, parentheses, arrow, get timer manager, parentheses, dot set timer, and then let's pass in the retrieve new tokens handle timer handle variable, and then this, and then ampersand u GameLift tutorial game instance, double colon, I made a typo here, but double colon retrieve new tokens. Oh, I also made a typo here. And then just like before, the next variable will be 1.0f because the next parameter is going to be false, so that 1.0f doesn't matter. And this time, instead of 60, we're going to make this 30.0f. And unlike the 60 that we set for the initial delay for the last time we set the timer for the retrieve new tokens function, we're going to keep this initial delay 30 here because this is calling the function again if there was some random error that occurred that prevented the request from even being made in the first place. And the last function that we will make in this class is the callback function for retrieve new tokens. So let's write out void u GameLift tutorial game instance, double colon on retrieve new tokens response received, and then in parentheses this function takes in 3 parameters. The first one will be fhttp request ptr request, comma, the second one will be fhttp response ptr response, comma, and the last one will be bool b was successful. And then don't forget some squiggly brackets at the end here. The first thing that we're going to check is if the request was successful in the sense that an actual connection was made, not that the request errored out because of a lack of an access token or the lambda function returned a bad response, but more so in the sense, did we even get a response back from the retrieve new tokens endpoint? So let's type out if in parentheses b was successful, and if the request was quote-unquote successful, let's go ahead and deserialize the response that we got back. So the response should be encoded in JSON. So let's make an object of type t shared ptr, and then in caret f JSON object, and we'll call this variable JSON object. And then for deserializing, we also need a object of type tJSON reader. So type out t shared ref, and then in caret tJSON reader carets, and then we'll call this variable reader, and we'll set it equal to tjson reader factory caret double colon create, and then in parentheses this function will take in a string parameter that should be formatted in JSON format. So let's pass in response arrow get content as string parentheses. Then let's actually deserialize the response content, which should be in JSON format, with the reader, and store that result in that JSON object variable by typing out if in parentheses f JSON serializer double colon deserialize, and pass in reader as well as JSON object, and then write some squiggly brackets. And let's check if that response JSON object had an error field by typing out if in parentheses exclamation point JSON object arrow has field, and then in parentheses and in quotes error. So if the JSON object from the response did not have an error field, then let's call the set Cognito tokens function, because if there's no error, then the response should have all the Cognito user pool tokens. So type out set Cognito tokens, and then let's pass in JSON object arrow get string field, and then in parentheses and in quotes access token, and then the second parameter will be JSON object arrow get string field, and then in parentheses and in quotes ID token, and then the last parameter that we will pass is just the refresh token variable that already existed in this class, because again we're just retrieving new access and ID tokens. Our refresh token should last for, again by default, I believe 30 days. If the deserializing of the response content string fails for whatever reason, let's try to retrieve new tokens again quickly. So add an else here for this if statement, and inside here we'll set the timer again like we did earlier for the retrieve new tokens function by typing out get world in parentheses arrow get timer manager parentheses dot set timer, and then in parentheses once again let's pass in retrieve new tokens handle this ampersand u GameLift tutorial, oh made a typo, u GameLift tutorial game instance double colon retrieve new tokens and 1.0f false and 30.0f, and then don't forget to add a semicolon at the end here. And again, the reason why that this function will be called in 30 seconds, not in loop, is because it's not that the request was malformed this time, it's just for some random Unreal Engine reason that we couldn't deserialize the JSON response from the retrieve new tokens API endpoint, which is very rare, which is why if this ever does happen, again this is an insane edge case, but if this does happen, then let's try to retrieve new tokens again very quickly while the access token is still valid. And another edge case that we have to account for is if the request was not successful due to connection issues, which is also again very rare, but we should deal with that because this time it wasn't a problem with the request or the response, it was mainly a connection issue. So let's add an else here, and let's actually copy this line up here because it's the exact same scenario. If for some reason we couldn't retrieve new tokens for reasons outside of the client's control, then let's try to retrieve new tokens again very quickly while the access token is still valid. And that is all the code that we need to write for the game instance. Just a note, for this tutorial series, we are assuming that the access token passed into any HTTP request we make to any of these API endpoints is always valid. So we should never receive a response with an unauthorized message. But even with our assumption, the if-else checks we wrote only cover small errors like if the JSON parsing failed or if there were any connection issues, which are very, very rare. We don't do error checking on not just the validity of the access token, but also the validity of the refresh token. The only way the refresh token could get invalidated is if it expired naturally after 30 days, which we won't deal with, and if you have multiple clients logged into the same account at the same time. When you quit out of one of those clients, then all the existing refresh tokens will be revoked. We won't be covering the situation either because ideally you should try to disable the ability to have multiple clients logged into the same account at the same time when your game goes into production, which is something I highly encourage you guys to explore on your own time. With that said, let's go ahead and build the project. And I am really sorry again, I made another mistake. I forgot that shadowing is not allowed in C++, so if you go back to your GameLift tutorial game instance header file, in the set Cognito tokens function definition, you can't make the parameter names the same name as existing variables outside of the scope of this function inside this class. For example, this access token name conflicts with this access token variable up here. So to fix this, let's just add the word new to each parameter name. So type in new for each of these parameters and then build the project again. Okay, the last thing we have to code now is in the main menu widget class, so let's go back to the main menu widget header file, and the first thing we're going to do is add an include statement for doing HTTP stuff. So let's type out hashtag include in quotes runtime /online /http /public /http.h. Then let's define some properties for the API URL and callback URL by writing uProperty parentheses f string API URL and uProperty parentheses f string callback URL. And we also need to define a U function to bind to a delegate on the web browser widget so that we can detect when the user gets redirected to the callback URL upon a successful sign-in. So type out U function parentheses void handle login URL change. And when the user does successfully sign in, this function will make a request to the exchange code for tokens API endpoint, and we will actually handle that response. So we need a callback function for that request. So type out void on exchange code for tokens response received. Notice how this isn't a U function like how we did before. And then in parentheses, this function will again take in the same three parameters as before. First one is of type http request ptr, and it will be called request. Second one will be of type http response ptr and will be called response, and the last one will be of type bool and called b was successful, and then end that line with a semicolon. Now let's go back to the main menu widget C++ class, and first go to the constructor and retrieve the URLs from the files we just added. So first one is the API URL, and that is going to be equal to text reader arrow read file, and then in parentheses and in quotes urls /API URL.text, just like last time. And then the second one is the callback URL, and that's going to be equal to text reader arrow read file, and then in parentheses and in quotes this should be the path to the file relative to the content directory. So it's going to be urls /callback url.txt. Next, let's set the onURL change delegate for the web browser widget to the new function we just defined. So go to the bottom of the native construct method and type out fscript delegate login delegate, and let's bind a function to this login delegate. So type out login delegate.bind U function, and then this function will take in two parameters. The first one will be this, comma, and then the second parameter will be in quotes the name of our function. So it's going to be handle login or URL change, and then add a semicolon, and then we actually have to add this delegate to our web browser widget. So let's type web browser arrow on URL changed dot add and then in parentheses login delegate. So now every time the URL changes in the web browser widget, our handle login URL change function will be called. But where is that handle login URL change function? Let's actually implement it by typing out void u main menu widget handle login URL change parentheses and then squiggly brackets. So the first thing that we are going to do in this handle login URL change function is define some local variables. So the first one will be of type f-string, and it will be called browser URL. And we are going to set it to the web browser widget's URL. So in this case, it will be web browser arrow get URL parentheses. And keep in mind that this will be the URL after it changes. So after a user signs in, and they get redirected to the callback URL when this function gets invoked for that specific URL change event, the browser URL in that case should be the callback URL plus whatever query parameters were passed into the URL. And then the next two local variables that we're going to make are going to be f-string URL and f-string query parameters. And the reason why I have a separate variable called URL different than the browser URL is that this local URL variable will store everything before the query parameters if they even exist. So let's not only check if the query parameters exist, but also split the browser URL at the question mark so that we have the base URL and the query parameters in separate variables. So let's write out if in parentheses browser URL dot split, and then in parentheses this function will take in three parameters. The first one will be the string that we split the string on, so in this case it will be in quotes question mark. The second parameter will be the string to the left of the question mark, assuming a question mark exists. So let's pass an ampersand URL for that, and then of course the last parameter will be the string representing everything to the right of the question mark, assuming again if it even exists. So for this one, let's type out ampersand query parameters and then some squiggly brackets. And if there are query parameters, if there is a question mark in the browser URL, then let's check if the base URL is the callback URL so that we know that this URL change event that triggered this function call was due to a successful sign-in, or not necessarily a successful sign-in, but a sign-in that resulted in a redirect to the callback URL. So let's check if in parentheses URL dot equals, and then in parentheses we'll pass in the callback URL, and then let's add some squiggly brackets. And if the user is currently looking at the callback URL, then let's make two local variables, both of type f-string, one called parameter name and the other called parameter value. And let's split the query parameters on the equal string so that we can get everything to the left of the equal sign to the right of the question mark, which should represent the parameter name, and everything to the right of the equal sign, which should represent the value for that query parameter. So let's type out if in parentheses query parameters dot split, and then in parentheses first parameter will be in quotes the equal sign, and then the second parameter will be ampersand parameter name, and then the last parameter will be ampersand parameter value, and then add some squiggly brackets. And we know that the sign-in request was successful if only one query parameter was passed, and that parameter is the code. So let's check if the parameter is called code by writing if in parentheses parameter name dot equals, and then in parentheses and in quotes the word code, and then some squiggly brackets. And if it is, then let's clean up the actual code value, because sometimes the code parameter in the URL may contain hashtags. These are not valid characters usually in the code, so let's go ahead and remove them by typing out parameter value equal parameter value dot replace, and then in parentheses star f string in parentheses and in quotes hashtag, and then comma star f string, and then in parentheses just a pair of quotes with nothing inside them, and add a semicolon here at the end. And then just like the last post request we wrote, same thing, let's make another request body JSON formatted string by first making an f-JSON object. So type out t shared ptr and then in carets f-JSON object, and we'll call this request obj and set it equal to make shareable in parentheses new f-JSON object. And then let's set a field in this request object by typing out request obj arrow set string field, and then in parentheses let's pass in the parameter name comma parameter value. And then of course let's make a local f string variable for the request body, and let's make a tjson writer object by writing t shared ref in carets tjson writer, and then carets again, call this writer and set equal to tjson writer factory in carets double colon create in parentheses ampersand request body. You may have noticed by these red squiggly lines underneath the text that we forgot some include statements inside this file, specifically for the JSON and JSON utilities header file. So go back up and type hashtag include in quotes json.h and hashtag include in quotes json utilities.h. And if you scroll back down, those red squiggly lines should go away. Now let's actually serialize the JSON object into a string by writing if in parentheses f JSON serializer double colon serialize, and then in parentheses request obj dot to shared ref parentheses and then comma writer. And if the serialization was successful, then let's make an IHTTP request object by typing out t shared ref and then in caret IHTTP request, and we'll call this exchange code for tokens request, and we'll set it equal to HTTP module arrow create request. Also, I just realized I forgot to define an FHTTP module member variable for this main menu widget class. So go back to the header file for this main menu widget class, and let's up here define the FHTTP module member variable by typing out FHTTP module pointer and call this HTTP module. And then let's go back to the main menu widget C++ class, go back to the constructor, and then in here we will instantiate an instance of the FHTTP module singleton from the factory, and then of course we'll set our HTTP module member variable that we just made to that. So let's type out HTTP module, set it equal to ampersand f HTTP module double colon get, and then parentheses. Then let's go back to making our HTTP request to the exchange code for tokens endpoint by first setting the on process request complete delegate to our callback function that we defined earlier. So ampersand main new widget double ampersand on exchange code for tokens response received. Sorry, I mistyped here, I forgot a U. And then on the next line, let's set the URL for this request. So it'll be exchange code for tokens request arrow set URL, and then in parentheses it'll be API URL plus in quotes slash exchange code for tokens, and then let's set the method type to post by typing out exchange code for tokens request arrow set verb in parentheses and in quotes post. Then let's set the content type header to application/JSON by typing out exchange code for tokens request arrow set header, and then in parentheses in quotes content dash type, and then comma in quotes application/JSON. Note that we are not going to be setting an authorization header for this request because this API endpoint we did not add a Cognito authorizer to this API endpoint. So anyone with the endpoint, with the URL, can call this API freely. So next thing we're going to do is we're going to add the request body to this request. So type out exchange code for tokens request arrow set content as string, and then in parentheses pass request body, and finally let's send the request by typing exchange code for tokens request arrow process request parentheses. Lastly, we are going to implement the callback function for this request. So let's write void umain menu widget :on exchange code for tokens response received, and then in parentheses http request ptr request comma http response ptr response comma bool b was successful. And then the first thing we're going to do, like we do with all of our http request callback functions, we're going to check if in parentheses b was successful, and if it was, then let's make a fjson object and we'll call it JSON object, and then we will make a tJSON reader object, typing out t shared ref and carets tJSON reader, and then carets again, and then we'll call this reader, and we'll set it equal to tJSON reader factory carets create, and then in parentheses we'll pass in the response arrow get content as string. So I made a typo, I forgot the Y in factory. Then let's deserialize that response JSON formatted string into a JSON object by typing out if in parentheses f JSON serializer deserialize, and then in parentheses reader comma JSON object. And if this deserialization was successful, then let's check if the response in the form of a JSON object has a field called error by typing out if in parentheses exclamation point JSON object arrow has field, and then in parentheses and in quotes error, and then some squiggly brackets, because if the response object does not have a field called error, then that means that we got a successful response return, a quote-unquote successful response return, meaning the logic went well, the lambda function was able to call the things that it needed to, and we have a response that does not have an error message inside of it. So first thing we're going to do, we are going to make an object of type uGameInstance, the project's game instance. So let's type out uGameInstance pointer game instance, and we'll set this equal to get game instance parentheses. And before we move on, I just realized I made a stupid typo on line 84 here when I called the get content as string method on the http response ptr object return. Make sure you have a pair of parentheses after get content as string because this is a method. So going back to where we left off, let's perform a null pointer check on our game instance. I know it's very rare for the game instance in this case to be null pointer, but we're going to do it anyway. So if in parentheses game instance not equal null ptr, and then squiggly brackets. If the game instance is not null pointer, then we will cast it to the GameLift tutorial game instance class that we made just now. But before we do that, we actually have to add an include statement for the GameLift tutorial game instance.h file. Once you have that, go back down and let's type out view GameLift tutorial game instance pointer, and then we'll call this variable GameLift tutorial game instance. And to actually perform the cast, we're going to set this equal to cast in carets view GameLift tutorial game instance, and then this cast function in parentheses will take in the game instance, and then we'll do another null check on the GameLift tutorial game instance, make sure that it's not equal to null pointer, and if it's not equal to null pointer, then we should be able to call the set Cognito tokens function. So type out GameLift tutorial game instance arrow set Cognito tokens, and this function will take in a few parameters. The first one will be JSON object arrow get string field in parentheses and in quotes access underscore token. So again, let me add a closing parenthesis there. Again, this is a string field from the response formatted as a JSON object. So second parameter will be kind of similar format. It'll be JSON object arrow get string field, and then in parentheses in quotes ID underscore token, and then the last parameter will be JSON object arrow get string field. Oh, sorry about that, guys, I forgot a closing quote here. So last parameter again will be JSON object get string field, and then in parentheses and in quotes refresh underscore token. So let's add a semicolon here at the end of this line. Let's build our project, and basically what will happen now when the user signs in through the Cognito hosted UI, and if they sign in successfully, our login URL change handler function will pick that URL change up. It'll get the code query parameter from the callback URL, and it will put that in the body of a request sent to the exchange code for tokens API endpoint. And upon a successful response return, assuming nothing went wrong, we will grab our game instance, and we will set the Cognito token properties inside that game instance, and that will also set the timer to retrieve new tokens every, right now, 60 seconds, which we will change later. Also in our game instance, because we overrode that shutdown method, if we quit our game naturally, then a request will be made to the invalidate tokens API endpoint, which will invalidate our tokens as you saw earlier. Okay, now let's go back to the Unreal Engine editor, specifically the main menu map. And before we play the game, let's actually tinker with some more settings by going to edit and go to project settings. And then from here, under where it says project, select where it says maps and mode, and then scroll all the way down because we have to set our project's game instance class. So click on this drop down menu that says game instance right now and select your custom game instance class. In our case, it's called GameLift tutorial game instance. So close out of that, go to file, and then select save all. Now play the level and sign in. And before you sign in, go to the bottom left and make sure you're on the output log tab, and then click sign in. And if everything went well, you should see a log statement here with the value of your access token. And in about 60 or so seconds, well, obviously less now because I talked a lot, you should see another access token pop up here. So just wait some time, and after about a minute, you should see another access token in this log. And one thing that you will notice, although it's not the most obvious, is that each of these access tokens are different. So what you can do to make sure that they are valid, let's just take one of them, and we'll copy that, go to Postman, specifically the retrieve new tokens request, and make sure you have the headers tab selected. And then for the value for the authorization header, let's actually select all of it by pressing Control A, and we'll paste in that new token that we just got. You might notice some red arrow marks here. That's because when we copied the token from the UE4 log, it may have added some new line characters. So let's get rid of those new line characters by clicking right to the right of that red arrow character. Just press backspace, do the same thing for the other one as well, and then press send. And if the access token is valid, you should get, in our case, because we didn't specify a request body with a refresh token in it, you should get a response saying error, incoming request did not have a refresh token. This is actually what we want to see if you didn't specify a request body, because if the access token was invalid, then you would have gotten message unauthorized or something like messaged access token was revoked, something along those lines. And if we go back to the Unreal Engine editor and actually quit the game, something I've noticed, for some reason this time, even though we overrode the shutdown method to call the invalidate tokens endpoint, you would think that if we click send again, that we would get something like message access token was revoked, but the access token is still alive and well, meaning that according to the Node.js AWS SDK documentation for the global signout method, it seems to be right. It seems that the access tokens for some reason now aren't getting revoked. So I did find that kind of weird. That's okay though. So let's go back to Visual Studio, because we still want to make sure that we're even calling the endpoint. I know I just said that we did call the endpoint, but let's just make sure. So let's go back to the GameLift tutorial game instance C++ class, where we actually log the access token. And this time, let's go ahead and copy this line, because we want to actually log the refresh token, because it seems like the only token that's getting invalidated by the global signout method is the refresh token. So let's replace where it says access on this line with refresh. And then let's right click the project again and select build. And then let's go back to the Unreal Engine editor and play the game. Sign in again. And pay attention to the logs for the access and refresh tokens. So let's take this access token right here, because we're going to need that. Go back to Postman, and then for the value here, just select all of it by pressing Control A, paste it in, get rid of the new, sorry about that, get rid of the new line characters, and then let's go to the body tab, and then select raw, and then under where it says, well, for you it might say text, for me it says JSON, but make sure here in this orange text, click on it, and then this drop down menu, make sure you have JSON selected. And then let's actually go back to Unreal Engine, and this time let's copy the refresh token value. So copy that, go back to Postman, and then let's type out squiggly bracket, and then in double quotes refresh token, and then colon in double quotes again, just paste in that refresh token value. And this is going to be a little tougher. Let's get rid of the new line. So everywhere where the text is blue, starting with where it's black, just press backspace. So starting with where the text turns black, just press backspace to get rid of those new line characters. Okay, and that should be good. And if you click send here, you'll notice that the refresh token works. We get a pair of access and ID tokens back, right? And if we go back to the Unreal Engine editor, another thing before I quit the game I just want to show you guys is, it's not very obvious, but when we got a new set of Cognito tokens, remember, we're printing out both the access and the refresh tokens. And again, I know it's really hard to see, but because the refresh token is valid for 30 days, we don't replace the refresh token, and we can't, because we wrote our Lambda function in a way so that we only get back new ID and access tokens. But if you notice in the logs, the refresh token stays the same. If you don't believe me, just use a text comparison tool in your free time, and then you can believe what I'm saying. But let's quit the game now, and if we If we overrode the shutdown method correctly, we should have called the invalidate tokens endpoint, and that should have invoked the global user signout method. I know before I said global signout, I meant to say global user signout. I think that's what the method is called. And if we go back to Postman this time and we click on send, you'll notice that it says error message refresh token has been revoked. That means we did call the invalidate tokens endpoint correctly. However, for some reason, what I said earlier about revoking access tokens was actually not true. The access tokens, and I guess ID tokens as well, for following the documentation, both of them do indeed stay valid for their entire lifespan until their expiration date, which right now by default is an hour after they've been issued. With that said, we don't have to retrieve new tokens every 60 seconds. Like I said earlier, that was just for testing purposes. So let's go back to Visual Studio, and inside the set Cognito tokens function, where I call set timer for the retrieve new tokens endpoint, let's replace this last parameter that currently says 60 with 3300, because that's 55 minutes in seconds, and that was the number that I wanted to use. You can use really any number. I would recommend under 1 hour, obviously, any number in minutes under 1 hour. And these log statements here for the access and refresh tokens, let's comment those out, because again, those were for testing purposes too. We don't really care about the access and refresh token from this point on. So let's go ahead and build our project and go back to Unreal Engine, and let's play the game one last time. Let's log in, and once again pay attention to the output log on the bottom of the screen, and you should notice that the log statements that we made for the tokens are no longer there. And that will pretty much conclude this part of the tutorial. We did quite a lot, more than I even expected. We set up a Cognito user pool, added Lambda triggers to the pool, added a web browser widget to our Unreal Engine project so that we could sign in through the hosted UI, and called Lambda functions through API Gateway from our Unreal Engine project using HTTP requests. If you made it this far, have enjoyed the tutorial series so far, and want to support the channel somehow, then I highly encourage you guys to become a patron on our Patreon to help support the channel. Each video in this tutorial series will be released on YouTube in full for free, so we don't really make money off these videos, and special thanks to those who are already patrons. Before I officially conclude the video, I'm just going to talk about some things to consider to help better secure your application that we won't be going over in depth. All the things that I'm about to say is what I personally recommend for an actual production application, so it is an opinion and will not apply to every single use case, so keep that in mind. 1. You should make it harder for users to make an account in order to enforce not allowing more than one account for each unique identity. When I say hard, I mean tactics such as one account per email or one account per phone number, and other forms of multi-factor authentication, because the more methods of authentication that you add to one account, the harder it is for someone to make more than one account, which may help with preventing mass spam attacks. 2. You should try to restrict the number of instances of your game client that can run on one computer to only one. Preventing users from running more than one instance of your client on a machine can help prevent different kinds of issues. 3. You should try to make it so that a user can only log into their account on one machine at a time, so enforcing the idea of one session per user regardless of the device being used. Because if you have someone logged into their account on a desktop and also logged into their account on their phone simultaneously, that could cause issues that you may be unaware of. 4. You should encrypt or hash the temporary credentials, so the Cognito tokens, while they are stored locally in the client application. This way, if the tokens were to get leaked, then at least they would have to be decrypted first before they can be used. 5. So earlier we decided that the player ID attribute in the players table in DynamoDB should be mapped to the Cognito sub-ID. Again, the reason we chose a sub-ID is that it is a unique value that will never change. I would avoid storing personally identifiable information on DynamoDB, as well as sending personally identifiable information back and forth through GameLift. Personally identifiable stuff could include email addresses, actual physical addresses, phone numbers, social security numbers, etc. The reason I mention this is that Cognito can hold stuff like email addresses and phone numbers because it's more secure and better suited for that than other AWS services. And that's why we avoided using the email address and phone number for that player ID partition key attribute. And although the Cognito sub ID isn't inherently personally identifiable information, the only flaw that I can think of with using the Cognito sub ID is that if someone got your user pool ID as well as someone's Cognito sub ID, then they could look up the user in the user pool and get all the information stored in that pool related to that user. Of course, this assumes that your user pool ID gets leaked, which may not happen, but if you wanted to add an extra layer of defense, you could encrypt or hash the sub ID before storing it in DynamoDB. This approach is probably not that necessary, but it doesn't hurt either. And 6, we are keeping the API endpoint URLs in the content folder, which will eventually get packaged with the rest of the game client. This may not necessarily be ideal because that makes it pretty easy for your API routes to be leaked, but keep in mind that API endpoints of the biggest games end up getting leaked to the public somehow, so instead of trying to hide your API endpoints, make the actual API methods and resources as secure as you possibly can. When these APIs are being called by public, not private applications, relying on your API routes to stay public almost never works. And that is finally it. We appreciate you guys watching. As always, don't forget to like, comment, and subscribe, join our Discord, and follow us on our other social media pages, and see you guys in part 6.